Hi everyone and welcome, I'm Gavin Lon. So, it gives me great pleasure to introduce you to this brand new free in-depth course that I've created for you. In this video, we are going to develop what I would describe as a next level application that leverages web scraping, webhooks, background services, .NET, C#, advanced C# concepts, advanced design patterns, Blazor, Azure Queue Storage, Azure Function, Azure SQL Server Database, and more. This video is sponsored by BrightData. BrightData provides a foundational service in the development of our application and enables us to successfully scrape the TIOBE index, Amazon, as well as YouTube for real-time data that we'll use as the foundation for our application. So, I'd like to thank BrightData for making this video and this application possible. We'll discuss BrightData's amazing services in just a bit. I'll first explain the application that we'll develop in this video, initially in very broad and basic terms, and we'll go over the application in detail as the course progresses. In this application, we are going to automate the scraping of data, firstly from the TIOBE index. That contains a table of the top 20 most popular programming languages in the world today, ranked in ascending order from 1 to 20. We'll capture the data scraped from the TIOBE index in our own database. Our system will then automatically move on to scrape Amazon for data pertaining to the latest textbooks related to each of the top 20 programming languages scraped from the TIOBE index. So the objective of this application is to automate the building of a library containing the most up-to-date educational resources pertaining to each of the top 20 most popular programming languages in the world today. After scraping and capturing educational resource information from Amazon, our system automatically moves on to scrape YouTube for data pertaining to YouTube channels that provide educational content for each of the programming languages scraped from the TIOBE index. So through our application, our users will be able to access the most up-to-date educational resources both online and in physical textbook format pertaining to each of the most popular programming languages in the world today. Once the relevant data has been scraped and captured from the TIOBE index, Amazon, and YouTube, the users of our application will be able to access the data displayed to the user in an aesthetically pleasing manner through a Blazor application that we'll create in this video. In this video, we'll start by creating a test environment so that we can develop and test our application locally, but ultimately, we'll publish all of the components that we'll build for this application on Microsoft Azure. The foundation of this application is real-time data. How can we capture real-time data from these disparate entities on the internet, namely the TIOBE index, Amazon, and YouTube? The best way, without a doubt, is to scrape the data from the relevant websites. We can, of course, create our own automated web scrapers to scrape the relevant data. So sure, we can leverage JavaScript to read the relevant HTML elements and CSS classes in order to extract desired data from the relevant websites. Creating the web scraping code is not an issue for us developers. However, one of the problems we'll need to overcome arises when hosting our own code from one IP address, because through repeated attempts at scraping the data, the security systems for the websites we are repeatedly hitting will invariably eventually raise a red flag. This can lead to our IP address being put on a blacklist and ultimately being blocked from subsequent web scraping activities on the website, from which we are trying to scrape desired data. One incredible service offered by BrightData is through BrightData's extensive proxy network. Your code can be executed from multiple different IP addresses so that you are not, for example, hitting the same website multiple times in a small time frame from one IP address. So through the use of BrightData's extensive proxy network, your IP address is rotated and therefore your web scraping is allowed to continue until you have scraped and captured your desired data. Let's look at BrightData's website. Over 72 million proxy IPs. Notably, BrightData facilitates web scraping at scale, meaning you can run hundreds of instances of a scraper at a time. BrightData handles solving capture problems on your behalf. Through BrightData's website, you can leverage an online IDE for creating and testing your web scraping functionality. You can leverage JavaScript, jQuery, and a number of built-in objects and functions that you can leverage within your web scraping code. BrightData provides a scraping browser that leverages Puppeteer, Selenium, and Playwright and automatically unblocks websites for you so that you can scrape websites for data that can be leveraged in your own applications. Note that you are able to gain credits for BrightData's services by using the relevant link that I've included within the description of this video. We are going to look at the details of how we can create and run our web scraping code using BrightData's scraping browser while we build our application step by step in this video. Crucially, we'll also look at the details of how we can integrate the BrightData functionality into our own application using BrightData HTTP endpoints to run our scrapers and a webhook that we'll facilitate using .NET's Web API project template to receive data notifications from BrightData and subsequently capture the scraped data in our application's own database. The fundamentals of our system can be described as follows. So, in this basic workflow involved in the system that we are going to create in this video, a message in JSON format is added to an Azure Queue storage service, which subsequently triggers an Azure function. The JSON message is passed to the Azure function, which contains information on which web scraper should be triggered on the BrightData platform and what parameter values should be passed to the relevant web scraper. The Azure function then makes a HTTP request to an endpoint hosted on the BrightData platform in order to invoke the relevant web scraper and passes in the relevant parameter values through the relevant HTTP request code. Once the web scraper is finished scraping the relevant website, for example Amazon, BrightData will call our webhook, which is facilitated using .NET's Web API project template. Our webhook code then saves the data passed to it from BrightData into a SQL Server Database. Our front-end code, facilitated as a Blazor application, can then read the data from the SQL Server Database and display the data in an aesthetically pleasing style to the user within the user's browser. So the application is fundamentally quite simple to understand, but we are going to look at some fairly advanced concepts as we progress through the creation of the application in this video. I will go through the advanced concepts step by step, so please don't let these advanced concepts put you off following along in the creation of this application. You will learn a tremendous amount going through this course. So, if you like this video, please hit the like button and please consider subscribing to the channel. Please also ring the bell so that you'll be notified of future content released from this channel. Please feel free to share this video with anyone you feel may enjoy and benefit from its content. If you'd like to thank me by buying me a coffee, you can do this at my Buy Me a Coffee webpage at this URL. It will of course be greatly appreciated. It would be great if you followed me on X. My username is @GavinLonDigital. I love reading your comments, so please feel free to engage with me in the comments section. While you go through this course, which demonstrates the fundamentals of how to integrate web scraping and data capturing functionality into your own systems, I want you to use your imaginations on how you can potentially use the functionality in this application as a basis for your own applications. The sky is truly the limit. Up-to-date data is like gold and sometimes even like oxygen to companies that wish to maintain a competitive edge in today's business environment. Data is, for example, foundational to AI systems. And as we know, AI is changing the world in profound ways. So knowing how to capture up-to-date data in real time is of profound significance to those who want to lead the world into the future. This is just the first part of the course, but the second and final part will soon be following. The second part, of course, will be released for free on this channel. Note that all the code created in this part of the course is available on GitHub. All relevant links are in the description of this video. The web scraping code can be found at this location. The WebHook code can be found at this location, and the Blazor application can be found at this location. We'll also create a .NET console app for testing purposes, and this console app can be found on GitHub at this location. Let's briefly discuss the technologies used to create the components of the application that we'll build in this video. You could use Visual Studio Code, but I would recommend using Visual Studio Community Edition for Windows. To create the code for this application, You can download the latest version of this software for free from this location. We'll use the SQL Server Database Management System and SQL Server Management Studio, SSMS, which can be downloaded for free from this URL. We'll use BrightData's IDE to develop and test our web scrapers. BrightData will host our web scraping code. You can get credits for using BrightData services by clicking on the relevant link that I have included below in the description of this video. Once we have developed and tested our code locally, we'll publish all of our code to Microsoft Azure. I will take you through this process step by step. So we of course don't want to run our code from our local machines indefinitely. We are going to want to publish our code to the cloud. So we'll use Microsoft Azure to host our application in the cloud once we have developed and tested our code on our local machines. Right, let's get into it. So in this part of the course, we are going to build the functionality to scrape the TIOBE index. If we navigate to this URL, we can see 20 programming languages ranked in order of popularity according to the TIOBE ranking system. The TIOBE Programming Community Index provides a reputable measure of popularity of programming languages. So in our application, we want to scrape the web page that ranks the top 20 programming languages and capture this data in our own SQL Server database that we'll design and create later on in this course. We'll later create code to scrape Amazon for data pertaining to textbooks relating to each of the top 20 ranked programming languages according to the TIOBE index. This data will also be saved to our SQL Server database. We'll then create code to scrape YouTube for data pertaining to YouTube channels that produce significant content regarding each of the relevant 20 ranked programming languages. Once we have scraped all the relevant data and captured it within our SQL Server database, we'll build a Blazor web application that appropriately displays these educational resources under each of the top 20 TIOBE index ranked programming languages. Ultimately, this web application that we'll create in this course provides developers and aspiring developers with a valuable guide to learning resources that can enhance their knowledge and potentially their careers. So this application provides a portal that consolidates valuable developer resources where valuable learning resources are available in one web application. So how are we going to scrape the relevant data from this TIOBE index web page? BrightData not only provides us with a network of IP addresses from which our scraping code can be executed, but also provides a facility where we can write our scraping code. This facility manifests as an online browser-based IDE, integrated development environment. Before we write our code, let's take a look at the front end of BrightData's platform. So let's navigate to brightdata.com like this. We are going to log in here. I've registered with this email address, my Gavin Lon Gmail address. You are of course able to log in with the password you created during the registration process, or if you registered using your Google credentials, you can choose the Google button here to log in to the BrightData platform. So I'm going to log in using a code that will be sent to my registered email address when I press this button labeled Send Me a Magic Login Link. And BrightData is now going to send a code to the address with which I've registered in order to authenticate me. Great, so I'm now logged in. In the sidebar menu option, let's click the button with the tooltip text, Web Data. One way to get started with creating our first web scraper or collector is by clicking this button marked Get Started, which is situated within the Web Scraper IDE panel in the bottom left-hand corner of the main web page. We are immediately presented with the IDE, which is what we are going to use to create our web scraping code. As we can see, a Modal dialog is presented to us in the foreground of our screen and is obscuring the IDE at the moment. This is to prompt us with template options that we can use for starting our web scraping functionality. We can either start our web scraping project using one of these templates presented on the Modal dialog, or we can start from scratch by pressing the Start from Scratch button. Before we start creating the code that we'll use in our project, let's quickly take a look at what happens when we select the Amazon template to start a scraping project within BrightData's IDE. We can see that we have two text areas where we can write our code, and we can see that templated code has been generated for us that is relevant to the Amazon template that we selected. The top section contains the interaction code. The bottom section contains the parser code. The interaction code contains code to, for example, navigate to the web pages that we wish to scrape. We can see here we have built-in methods provided within BrightData's IDE, like navigate, which can be leveraged within our scraper or collector projects to navigate to the relevant web pages that we wish to scrape. Here we have input.url, which means an input parameter named URL is expected by our interaction code created here within this text area. A URL object is being created based on the URL input passed to this code from an external source, for example, calling code executed by a .NET application, which is code that we are going to implement during this course. So we are able to use BrightData's relevant built-in objects and methods to, for example, construct a URL with search parameters. We can then use BrightData's platform to target the relevant URL in order to scrape the data that we want to capture within our own database. This Amazon template contains code to scrape data pertaining to a specific Amazon product. So the input that this code must receive is the URL pertaining to a product currently sold by Amazon. So this is a web page on Amazon that contains details about a product that we are able to purchase through the Amazon website. Let's take a look at the parser code section. This text area marked parser code allows us to write code to extract the data from the markup code used to create the relevant web page that is navigated to from the code within this interaction code section. The parser code, for example, reads the HTML elements, i.e. the HTML tags, as well as relevant CSS class references within the relevant tags to extract data from the web page. jQuery, which is a JavaScript library, and JavaScript are the languages or technologies used to read and extract the data from the targeted web pages. So here we have code already written for us because we chose to start our project using the Amazon template. So here the code is navigating to a web page that displays data pertaining to a particular Amazon product. Here is code written in jQuery and JavaScript that traverses the relevant HTML elements and style sheet classes to target the relevant data on the web page. So in this way, the web page can be appropriately traversed and the desired data can be extracted and saved to an object or array of objects and subsequently be returned to the calling code in the interaction section, where the data can be collected and returned to external calling code. We can see here at the end of the parser code section, the variable named data is being returned. Within the interaction code, the parse method is called, which is how the value contained in the variable named data is returned to the interaction code. So the parse method returns the data that has been extracted from the targeted web page in the parser code. BrightData's built-in collect method is used for collecting the data returned from the parser code. So here we can see the parse method is being passed into the collect method. The data collected within the parser code is collected in the interaction code and returned to the calling code. The calling code in this case may be, for example, a .NET Web API component. We are able to click a button situated on the top right-hand corner of the interaction code section to look up and learn about built-in functionality provided to us in BrightData's IDE. Here is also a button situated at the top right-hand corner of the parser code section where we are able to look up and learn about built-in functionality provided to us. Notice that we are automatically able to use jQuery. We can see here are a number of tabs, for example, input, output, children, run log, browser log, etc. In the input tab, we are able to create parameters that we can pass to our interaction code. Here, the URL parameter has been provided for us because we started this project using the Amazon template. So this URL points to a web page containing data pertaining to a specific product sold on the Amazon website. The inputted value can be referenced by code within the interaction section using BrightData's input object. An example URL has been provided for us within the URL parameter in the input tab. So let's navigate to this URL within our browsers. And we can see here that that product is a pair of trainers or running shoes. So we could write our own scraper or customize the Amazon template here with our own code. We could, for example, take a closer look at this web page's source code through our browser. We can inspect various elements and analyze how to extract desired data from the web page. We can then integrate our own custom code with the template created code here. That was generated when we chose to start our scraper project using the Amazon template. Once we are happy with our scraper code, we can test it by first ensuring we have inserted valid parameter data into the relevant parameters here. Here we have the URL parameter, and then press the preview button. BrightData then runs the relevant code and scrapes the desired data from the relevant web page. Step-by-step status is provided within the run log page as our scraper code progresses. Once the code is finished scraping, we can see within the Output tab our results. We can then press the eye icon to get a better view of the data that is presented to us in JSON format. We can also download the data by pressing this download button here. The results are then downloaded through our browsers as a JSON file. So the JSON data is presented on one line within Visual Studio here, but I'm able to format the data appropriately on multiple lines by right-clicking within my code editor and selecting the Format Document menu option. We can then examine the results, and if we are happy with our results, we can then save our scraper code to development or production. Or we may wish to continue developing our scraper until we are satisfied with the results that our scraper code is returning. So we could press the Finish Editing button here, which means we can then make this code available as an endpoint so that it can be called from an external source, for example, a .NET application. A little bit later in this course, we go into the details of how we can make our scraper code available as an endpoint once we have created our first scraper, which will be a scraper that scrapes the TIOBE index. So we can delete the scraper like this because the scraper is just intended as an example. used to introduce us to BrightData's IDE. Let's develop an actual scraper that we'll use in our own application. This scraper will target the TIOBE index and return all 20 ranked programming languages. The scraper we'll create is a very simple scraper that will return specific fields from this HTML table representing the relevant TIOBE ranked programming languages. So here are the fields that we want to scrape from the table containing the TIOBE index ranked languages. So the first field is the number representing the order in which the relevant language is ranked. So for example, number 1 is Python, number 2 is C, number 5 is C#, etc. We are going to scrape the programming language names, for example, Python, C, JavaScript, Java, C#, etc. We are also going to scrape the path for the image that is being used to represent the relevant language in the table that displays the TIOBE index ranked programming languages. In our application, we are going to capture all this data in our own SQL Server Database. We'll then be able to display this data in our own custom way within our own Blazor application. So let's create our first scraper. So I've already created the prototype code for our scraper. Here is the finished code for the prototype code that I created off screen. We are now going to create this code step by step. But let's first look at the prototype code within BrightData's IDE. In the interaction part of the code, the web page that contains the TIOBE index ranking is targeted. Within the parser code, the HTML table that represents the programming language rankings is targeted. Each HTML row within the HTML table denotes a programming language. Each HTML column within the relevant rows contains a field pertaining to the language as well as its ranking order. So if we run a preview of this scraper, we can see that it scrapes and returns the desired data. We can download the data to our local machines by pressing this button. And then we can verify the accuracy of the data by, for example, checking the path of some of the images pertaining to some of the programming languages. So here we are appending the relative path of the relevant images to the base URL of the TIOBE index, and we can see that the correct images are being targeted. We are later going to implement code within our own Blazor application to appropriately display these images. So let's start from the beginning and create this code that scrapes the TIOBE index step by step. Let's click the button that has the tooltip text WebData located in the left-hand side menu bar here. Let's select the My Scrapers tab. We can see a list of all the scrapers that I've currently created. 3 scrapers were created by me off screen in preparation for this course. We are going to create each of these scrapers from scratch in this video. So to create our first scraper that scrapes the TIOBE index data, let's click the button marked Develop a Web Scraper in brackets IDE here. This time we aren't going to use a template because we want to develop this scraper from scratch, so very minimal amounts of boilerplate code will be generated. So let's press the button marked Start from Scratch. Great. So some code has been generated in the interaction section as well as the parser section, but not much. The scraper that we are about to code is relatively simple. In the interaction code section, let's write the code that navigates to the TIOBE index web page. So to do this, all we need to do is pass the relevant URL into the navigate method. So within our browsers, let's navigate to the web page that displays the TIOBE index. Let's copy the address of this URL to our clipboards and paste this URL address into our code so that the relevant address is passed as a string argument to BrightData's built-in navigate method here. In the interaction code section, this is the only other alteration we need to make to the existing code. So here we are basically returning the passed data. The data that is passed is, of course, the data found at the URL that we have passed into the navigate method. We'll create the parser code in a bit, and then we use the collect method to capture the data, which means this passed data can be returned to an external source, for example, a .NET client application. So we are just passing the code returned from the parse method into the collect method here. Of course, we haven't yet written the parser code. So let's go to the parser code section and write our parser code. Firstly, let's create a const that references all the HTML rows within the HTML table that contains the data for the programming language rankings. We can achieve this with this line of jQuery code. Let's initialize an array named rankingAr. This array will store our scraped data that we'll return to the interactions section that will subsequently return our collected code to, for example, an external calling client, like for example a .NET application. Then using the each method, we are able to traverse each of the rows contained in the all rows const. Using the find method, on each row element, we can target the relevant HTML columns. So the text from the first column that we wish to extract is the ranking order number. So for example, Python is ranked number 1, so 1 will be extracted. C++ is ranked 3rd, so on the 3rd iteration of the loop, 3 will be extracted, 5 will be extracted for C#, and so on. We can grab the text representing the programming language name from position 4 in the columns array like this. To grab the image path or the relative path for the image that represents the relevant language, we have to do a little bit more work. We first get a reference to the TD or HTML column. Then using the find method, we can find the image element contained within the relevant TD element. We can use the src attribute to extract the path of the image using the attr method. We can then create an object representing data scraped from each of the relevant rows within the relevant HTML table and push each object into a JavaScript array with this line of code. Then in the return section, let's replace the code that was auto-generated with the name of the array we wish to return to the interaction code. And you can see in the interaction code that the built-in parse method is used to return the data from the parser section. The relevant interaction code then collects this data, and the data can now be returned to the external calling client code, which could, for example, be a .NET Client application. This scraper doesn't require any input parameters. Its function is to navigate to the web page containing the TIOBE index, ranked languages, and extract data that we have deemed as significant, i.e. the ranking order number for each programming language name, and the relative path for each image used to represent each programming language. So we need to fix our code here by adding a closing bracket like this. We can preview our code by pressing this play button. We can test our code through the IDE or preview the results of our code. Once our scraper has finished running, we can press this eye icon here to clearly review our results. We can also download our results, which are in JSON format, to our local machines by pressing this button. We can then verify that the data we have scraped meets our requirement. Once we have previewed the running of our code and are happy with the results, we can click the Finish Editing button here. So we are able to configure this scraping code or collector that can then be called as an endpoint from external sources. We can further test our code and initiate our code manually on the Initiate Manually tab here by pressing this button marked Start. Once pressing the Start button, the Runs tab is in focus and we can see status pertaining to previous runs of our scraper as well as the current run. As we can see, our scraping code is running. This is denoted by the small data collection animation being presented to us, as well as the current disablement of the button here on the left marked Download File Options. And the Download File Options button is now enabled. So let's click the Download File Options button. We can see that we have options to download the data returned from our scraper in a number of formats, for example CSV, JSON, etc. So let's choose the JSON option and download the data returned from our scraper. Let's find our downloaded file. So my downloaded JSON file automatically loads in Visual Studio. And if the data is displayed to us on one line within Visual Studio like this, we can right-click and use the Format Data context menu item to format the JSON data in a readable format. Great! Let's go to the My Scrapers tab and let's rename our collector to something sensible. It currently has a default name which is New Collector. Let's name the scraper TIOBE2. I had already written the same code before while preparing for this course, and that scraper was named TIOBE. But for some reason I erroneously put an I at the end of TIOBE instead of an E. Oops, first spelling error. So I'll make sure that I use an E this time. So TIOBE2 is our new scraper, and the next step is configuring through the BrightData platform how we want the relevant data delivered, for example directly through an API call, or we can have the data delivered asynchronously through what's known as a webhook. So we are going to use a webhook as our delivery method. This means that we are introducing an asynchronous mechanism within our system. So the synchronous approach would, for example, call a HTTP BrightData endpoint that denotes our scraper. Our .NET client code would then pause code execution at the line of code that calls the relevant HTTP endpoint. Subsequent lines of code would only continue executing once the endpoint returns the relevant data to the .NET client or an error occurs. With the asynchronous scenario, we can, for example, initiate the scraper from an Azure function that runs on a schedule, for example at 2 a.m. every morning. Once the scraper is finished collecting all the data, it delivers the data to a webhook that we'll create. So the Azure function that initiates the scraper on the BrightData servers is in no way directly connected to the webhook code that receives the data. Our webhook will simply be an application based on the .NET Web API project template that will listen at a particular HTTP address. We'll configure our BrightData scraper to deliver the scraped data result to this HTTP endpoint where our webhook will be listening. Sometimes a webhook is referred to as a reverse API. This is because instead of calling the external web API from our client code, with a webhook, we are creating an API HTTP endpoint, then registering the URL that denotes the HTTP endpoint with an external entity, in this case, the BrightData platform. So by registering a HTTP endpoint that we will create, i.e., that will denote our webhook, we can receive data notifications from BrightData once the relevant scraped data is ready. So by doing this, we will have effectively introduced an asynchronous process into our system. An Azure function initiates the scraping on BrightData by calling the relevant endpoint to do this. When BrightData has finished scraping the data, this data is not returned directly to the Azure function. It is returned to our webhook once it is finished scraping the relevant data. Our webhook will then process the data, which means it will save the data to our own SQL Server Database, which we'll design and create in this course a little bit later. A separate Blazor application that we'll create in this course will then read the data from our SQL Server Database and display the data in an aesthetically pleasing way to the user. So you can see we have three separate processes in our application that don't know, as it were, anything about one another. They are not directly connected to one another. We have the Azure function that initiates the scraper on BrightData. BrightData calls our webhook when it is finished scraping, and our webhook saves the relevant data passed to us by BrightData to our SQL Server Database. A separate Blazor application running at a completely different URL to the webhook can be invoked by the user of our application, and they'll be presented with the scraped data in an aesthetically pleasing way on our Blazor front end. So the data will be displayed to our users in a customized way. So in order to create and test the Web API project that will serve as our webhook, we need to firstly set up a testing environment on our local machines. We are going to use free software known as ngrok as a key part of our local testing environment. So what is ngrok? And how are we going to use ngrok to create our testing environment? Basically, ngrok provides tunneling functionality, which means we can essentially run our .NET Web API project from Visual Studio on our local machines, and ngrok can provide an IP address which will be available publicly on the internet. We'll configure ngrok to map the IP address to the local HTTP address on which our webhook will be listening. So this essentially makes our webhook publicly accessible to anyone who knows the relevant ngrok created IP address. We are then able to appropriately register this ngrok generated IP address as part of our webhook HTTP endpoint URL with BrightData. So in this way, we can initiate the relevant scraper on BrightData. When our scraper running on the BrightData platform is finished scraping, the result can then be delivered to the webhook running on our local machines. We can then test and debug our webhook on our local machines. So we can develop the code on our local machines that handles the data notifications sent to our webhook from BrightData. We can test our code that processes the scraped data and inserts it into our SQL Server Database. Don't worry if any of this is a bit vague at the moment and doesn't make sense. We are going to go through this whole process step by step. Before we install ngrok, let's firstly create our webhook, which, as mentioned earlier, is just a project based on the .NET Web API project template using Visual Studio. Firstly, let's create a local folder and name it Learn IT Resources or Learn It Resources. Learn It Resources is the name of our fictitious company for whom we are creating this application. Let's fire up Visual Studio. So we can use these drop-down lists to appropriately filter our .NET project templates. Let's select the ASP.NET Core Web API project template here. Let's select the local folder in which we'll save the code for our Web API project. Let's name this project Learn It Resources BD API. BD, of course, stands for BrightData. Let's press the next button. We don't need to change anything on this page, so let's press the Create button. If we open the program.cs file within our project, we can see that by default Swagger and Swagger UI has been configured for us through the appropriate middleware configuration code. This means we will be able to test our API endpoints from a UI that it generates for us by default. So by default, code for a web forecast controller is created for us. We can test this through Swagger by running our code through Visual Studio like this. We can then use Swagger to run the weather forecast controller code like this through the Swagger UI. So the code within the weather forecast controller simply returns made-up weather forecast data. Testing this allows us to make sure the infrastructure created through Visual Studio is working correctly before we write our custom code to address our specific requirement. Great! So let's create the controller for our webhook. The code for our API is based on the MVC design pattern. M stands for model, V stands for view, and C stands for controller. So to create our controller class, let's right-click the controllers folder and select the add controller ... menu option. We don't want to select the default option here. This option is appropriate for our MVC web application controller. We want to select the option that is appropriate for the web API controller option. So in the left pane of the dialog, select API, then in the right pane, select API controller empty, then click the Add button. So a new dialog box is presented to us. From this dialog box, we don't have to change the list item selected because the default option is the one we want to ensure that the API controller-empty option is selected in the list. And let's name this controller Handle BD Data Webhook. Let's press the Add button. So within the Handle BD Data Webhook controller class, let's create an action method that denotes a method created for the purpose of handling post requests for the Handle BD Data Webhook controller class. So let's make this an asynchronous method through the use of async await task. So firstly, let's create a try-catch block. Let's assign the body of the HTTP message posted to this method to a variable named request_body. So in order to convert the body of the message from a stream to a string, let's create an extension method that can be called on the body property of the request object. So let's create a folder named extensions. Within the extensions folder, let's create a class named HTTP request extensions.cs. Let's make this class a static class because this is part of the rules associated with creating extension methods in C#. Let's create a static async method named readAsStringAsync. We can see that the first parameter is of type stream. This parameter is preceded by the this keyword. With extension methods, the first parameter is always preceded by the this keyword. This first parameter denotes the object on which this extension method is called by client code. So the first parameter value that is passed into the method is the object on which the extension method is called. The second parameter is an optional Boolean parameter, and let's set it to false. So let's write the body of the code for our extension method. The first line creates a stream reader object to read in the stream from the post request received by our post action method. The second line uses a method named readToEndAsync, which converts the stream from start to finish into a string. The returned result is assigned to a variable named body as string, which is subsequently returned to the calling code. So now, if we go back to our post method in the handle BD data webhook controller class, we are able to invoke our extension method on the request.body object like this. And note that Visual Studio automatically adds the namespace using directive to provide the namespace in which our extension method resides. The reason I'm writing the code like this is because BrightData is going to be returning JSON formatted data of varying types at different points in our process of capturing the scraped data. So we are going to dynamically analyze and typecast the data passed to our webhook or post action method as is appropriate. You'll see the details of what I mean by this as we progress with the development of this application. So we are so far taking the data posted to us and converting it into a string. So at this point, we have a string in JSON format. So in this line of code, we are taking the string that is in JSON format and converting it into the dynamic data type that is available to us in C#. C# is a strongly typed language, and ordinarily it is best to always use the type system in C#, which means strongly typing our variables. This can lead to better robustness of code at runtime as well as better performing code. In this case, however, where performance is not that essential, we have unusual circumstances where we are dealing with data delivered by a third party. We don't necessarily know the type of data that is going to be delivered to us at various points in the process. So we can use the dynamic type to circumvent the C# type system, and we can typecast the data posted to us at runtime rather than at compile time. So by using the dynamic type in C#, we can circumvent the C# type system, and the C# compiler won't complain, as it were, at compile time that we are not using a strongly typed variable in this particular case. So this allows us to deserialize the JSON data that at this point in the code is a string into an object without the need to convert the JSON data into a particular type. So we want to use Newtonsoft to deserialize the JSON data, which is a string at this point. Visual Studio is complaining and has put a red squiggly line under JSON convert, which is part of Newtonsoft. So this is because we haven't yet installed Newtonsoft. So to install Newtonsoft and include the appropriate Newtonsoft namespace directive, we can hover our mouse pointers over the red squiggly line, click the link in the pop-up message labeled Show Potential Fixes, and select the menu option marked Install Package Newtonsoft.json, and then select Find and Install Latest Version. Note that you could have also installed Newtonsoft by right-clicking the Dependencies node within the Visual Studio Solution Explorer window and select the Manage NuGet Packages ... menu option. Then you could search for Newtonsoft and install it. Great, so we have now installed Newtonsoft, and the JSON convert.deserialize object method will deserialize the relevant JSON string into an object. Okay, so let's write code to write the JSON object to the console screen. So this in effect will convert the object back into a string, but this code is only for testing purposes, so the console.writeLine code can be removed for the production version of the code. This code provides us with a mechanism to inspect the JSON data passed to our webhook from BrightData while we are running our webhook on our local machines during the development and testing phase. So we now have some code that we can test within our webhook. Before we continue with the development of the logic for our webhook, let's test the mechanism of BrightData sending our webhook a data notification once the relevant scraper has finished scraping. Before we test our webhook, let's write code to return a status code of 200 or OK to the calling code for when the code reaches this point. If, however, an error in our code is thrown, let's handle the exception by writing the exception to the output window and then returning a status code of 500, which means an internal server error has occurred. And we must also remember to decorate the post action method with the HTTP post method attribute like this. This means that our post method will be accessible via a HTTP post request issued by external calling client code. And note that I've put a breakpoint in the code so that when we test our webhook, our breakpoint should be hit when BrightData sends our webhook a data notification. So the next step is enabling our webhook endpoint to be publicly available on the web. As mentioned earlier, we are going to use ngrok for this purpose. So let's download and install ngrok. So in order to download a free version of ngrok, let's go to this URL. Assuming you are not signed up yet, you'll need to sign up in order to get your free version of ngrok. So to do this, firstly click the Sign Up for Free button. You can sign up with your Google or GitHub credentials, or you can sign up by providing a username, email address, and password. So once you're signed up and logged in, make sure the Setup and Installation option is selected in the left pane. I'm on a Windows platform, which means I will simply follow the instructions presented to install ngrok on a Windows platform. You're also able to install ngrok, for example, on a Mac platform. Simply follow the relevant instructions to do so. On my Windows platform, I used Chocolatey to install ngrok. To do this, simply run your command console window as administrator, type choco install ngrok, then press enter. Then run the command here to add the relevant auth token to the ngrok.yaml file. So now it's actually very simple to use ngrok. Firstly, let's navigate to our Web API project loaded within Visual Studio and double-click the node in Visual Studio Explorer window that represents the launch settings.json file. We can see that if we run our project using HTTP as opposed to using HTTPS, we will be running the project on port number 5165. Your port number will no doubt be different to mine, but you are able to get the appropriate port number from your launch settings.json file here. ngrok will provide a HTTPS address to external sources that will have access to our webhook that will be running on our local machines. Note that we must run our webhook, our Web API project, through Visual Studio using a HTTP address and not a HTTPS address. So let's use ngrok to create an IP address that we can then register as part of our webhook address with BrightData as our delivery preference, i.e. when we declare our delivery preference on the BrightData platform, so that the relevant scraper can access our webhook and deliver the relevant scraped data to our webhook. Firstly, let's run our console command window as administrator. At the command prompt, type in the command ngrok http 5165. 5165 is of course the HTTP port number, which is part of the HTTP address on which my locally run webhook will be listening. Your port number will no doubt be different on your local machine. Then when we press the enter key, we can see that ngrok has generated a HTTPS address for us. So keep the command window open and let's navigate to the BrightData platform. Let's navigate to the My Scrapers tab. Select the Initiate Manually menu option next to the TIOBE 2 scraper. You may have called your scraper something different. Then select the button labeled with the 3 dots here and select the menu option labeled Delivery Preferences. Note that the delivery strategy field should remain as API download and must not be webhook. Then we must scroll further down the page to the field labeled When Finished, Notify Me By. We can see 3 radio buttons labeled None, Email, and Webhook respectively. Please select the radio button labeled Webhook. We are now dynamically presented with a field labeled URL. We can now fill in this field with the ngrok IP address followed by the path of our webhook. So the path to our webhook is the ngrok path followed by a /, then followed by text API, then followed by the name of our controller class, which is handle BD data webhook. So let's go back to the command window and let's copy the IP address generated for us by ngrok to our clipboards. Let's go back to the relevant BrightData web page and fill in the URL field, which is the address at which our webhook will run on our local machines. So let's paste in the URL generated by ngrok into the URL field. Let's add a / after this, followed by the text API. Then let's add another / followed by the name of our controller class that contains the code for our endpoint within the post action method. So the name of our controller class is handle BD data webhook. So now let's go to Visual Studio, and where the play button is on our toolbar here, let's select the drop down next to it. Then let's select the HTTP option here. We of course need to run our project locally with a HTTP URL and not a HTTPS URL. Then let's click the play button and run our project locally. Let's go back to the relevant BrightData web page and make sure that BrightData can successfully access our webhook endpoint, which is of course running locally on our local machines. So to test this, we can press this button marked Test Webhook. Great, so our breakpoint within our post action method within our webhook is hit. So you can step through the code or simply press F5 to run through the code. We should see a message positioned below the button marked Test Webhook, and the message should state the following: Sent sample collection to test delivery. This message should also be preceded by a tick icon. Excellent! And if we navigate to the command window, the one created from running our webhook code through Visual Studio, we should see printed to the screen a sample message sent to our webhook from BrightData. Excellent! So we can now scroll down to the bottom of the Delivery Preferences webpage for the TIOBE 2 scraper and press the Update button to save our delivery preferences for the TIOBE 2 scraper on the BrightData platform. So this means we have now registered our locally run webhook with BrightData, which means BrightData can now send our webhook data notifications once our TIOBE 2 scraper has finished running. This ultimately means our webhook is able to receive data results obtained through the running of our TIOBE 2 scraper. So now that our webhook has successfully been sent a test notification message from the BrightData platform, you are ready to progress to the next part of the course because you have now successfully set up a test environment where you can receive scraped data sent to your webhook running on your local machines from BrightData. Excellent. So let's create a console application using Visual Studio so that we can kick off, as it were, the scraping process on BrightData's servers using code that we'll create within the console application. So this console app is just a temporary application to help us test the process of starting the relevant scraping process on BrightData's servers from our local setup. And then once BrightData has finished the relevant scraping process, BrightData will send appropriate data to our webhook. The infrastructure for our webhook is now in place within a .NET Web API project we have now created. So this console app will be created to help us with the development of our webhook code, and will also become the basis for code that we'll create later on in this course within an Azure function project. The Azure function code will be triggered when JSON data is inserted into an Azure Queue storage service that we'll create on Azure at the appropriate point in this course. Let's first create this console app, and we'll create the Azure function and Azure Queue storage service later in this course in order to replace this console app. This code that we create in this console app will be reused later within our Azure function. So let's create a local folder within our local development storage structure to house our console application. Let's give the folder a sensible name. I'm going to name my folder Test. Let's fire up an instance of Visual Studio and select the .NET Core Console App project template from within our dialog here. So I'm going to name my console app appropriately. I'm going to call my console app Test Scraper. Then you can select the local folder that you created earlier for this location field. And we don't need to change anything here, so let's click the Create button. So before we start writing code, let's navigate to the BrightData platform. Let's navigate to the My Scrapers tab and let's click the three dots here next to TIOBE 2 and let's select the Initiate by API menu option. So we can see here in the top text area box, we have a command that can be used to manually initiate the scraper through a call to the endpoint provided here within the text area box. Essentially, this is a HTTP call placed to an API that will trigger our TIOBE 2 scraper to run. So we just want to copy the URL from within the text area box that denotes the relevant endpoint that will kick off, as it were, the TIOBE 2 scraper to our clipboards and paste it into our console app. We can then write code using the .NET HTTP client object to call the relevant endpoint from within our console app. So we'll use this URL in our code in just a bit. Let's comment it out here. So let's instantiate an instance of the HTTP client class like this. Let's create a variable named requestURI and assign it the value of the URI for the endpoint that we have just copied from the BrightData platform. So let's create the code for the post request that we'll send to the appropriate HTTP endpoint. Notice that immediately after I include the await keyword, that Visual Studio automatically adds the async keyword to the definition of the main method. This becomes a problem later on. We'll look at the issue this causes in just a bit. So we are using the post async method called on our HTTP client instance and passing the variable that stores the endpoint URI as the first argument to the post async method. The second parameter expects an input value to be posted to the relevant endpoint, but no input parameters are required for our TIOBE 2 scraper, so let's pass null into the second parameter. We are assigning the returned response to a variable we have called response. This response object should contain the data telling us, as it were, if the HTTP post request has been successful. So we should receive a status code of 200 or OK. So for testing purposes, let's write out the response object's status code to the console screen using the WriteLine method. So we must also create the code that sends a security token as part of the header information with the relevant HTTP post request. So we can use this code in order to add the security token to the header of our HTTP post request. So as you can see, name value pair data is expected to be passed to the constructor of the authentication header value class. The first argument denotes the name, which is bearer, and the second argument must be the relevant security token. So the name is bearer, the value is the relevant security token. So the next step is to create a security token on the BrightData platform. So let's go to the BrightData platform. Let's click the settings icon here within the left menu bar and then select the account settings menu option. And below the API tokens heading, we are able to create a new API token. I've already created an API token. You'll need to create a token if you have not yet done so and then copy it to your clipboard. When you create the token, set the permissions field to admin and set the expiration date field to unlimited. Note that if something goes wrong, you are able to revoke your token and create a new one. Please note that the token that I will be using in this course will be revoked by the time you go through this course. Okay, so once we have copied our security token to our clipboards, we can then appropriately paste the token within our code. So of course the way I'm doing this here, exposing the token within my code, is not very good practice. This token should be stored as a secret and not exposed like this in code. I'm doing it like this just in the interests of time. So if you're actually creating an application, for example in a team situation, protocols should be set up so that access is appropriately limited to sensitive security information. Great. So the value of our bearer token is now being passed into the second parameter of the constructor of the authentication header value class. So the other header value we can pass with our post request is to indicate that our client application accepts data in JSON format. Okay, so let's run the code to kick off, as it were, our TIOBE 2 scraper. But before we do that, let's make sure our webhook is listening. So let's run our web API project first. Let's run the console app code. So when I try to run the code, I'm getting this error. Program does not contain a static main method suitable for an entry point. Do you remember when Visual Studio automatically added the async keyword to the main method definition when we included the await keyword before typing in the post async code. The reason the compiler is complaining is because we are using async await functionality within our main method, which means we need to change this void return type to task within our main method definition. So we need to follow the rules when implementing async await task functionality. So let's do that. Let's change void here to task and see if our code compiles. Great. Okay, so let's try to run our code again. Great, and we can see that the post request has been successfully received on the BrightData platform, and we are receiving a HTTP status code of OK from our response object. So the HTTP status code value is 200, which means OK. And if we navigate to the TIOBE 2 scraper on the BrightData platform, on the Runs tab, we can actually see that the TIOBE 2 scraper is running. The Download File Options button is currently disabled, and under the Trigger field, we can see this little animation. Within this row, we are able to see status information updates in real time. Okay, and now the Download File Options button has just become enabled. We can see the status of the crawl on the BrightData platform here by looking at the relevant field values associated with the relevant run. For example, records, failed crawls, and fulfillment. And if we go to the output of our webhook, we can see that BrightData has sent relevant information regarding that particular run of the TIOBE 2 scraper to our webhook. Our webhook code is currently printing this information to the screen, which we can see here. So we have two particularly important values here, namely the ID value and the collector underscore ID value. So the collector underscore ID value is a unique identifier used to identify the scraper or collector, and is the unique identifier given by BrightData to our TIOBE 2 scraper. So you'll see in a bit that this value is very important to us when we write code in our webhook to identify the relevant collector. So this allows us to differentiate between the three collectors or scrapers that we'll create in this course. The ID value is associated with a particular run of the relevant scraper. This value is important because at this stage, we are only being notified that the scraper has finished processing and that the data is ready to be sent from BrightData to our webhook. So at this point, we still need to send a HTTP GET request from our webhook to the relevant BrightData endpoint in order to retrieve the actual results of the web crawl performed by our scraper or collector. When we initiate the HTTP GET request, we must include this ID value with the GET request in order to tell BrightData, as it were, which dataset we want returned to us. We'll look at the details of the GET request for retrieving the scraper results from BrightData in just a bit. So now that we have the basics for our test scraper console app coded, and therefore we are able to run our scraper on the BrightData platform from our local environment, let's progress with the coding of the webhook. So let's go to our Web API project. So we need to have a HTTP client object available to us. So let's open the program.cs file. Let's include this code so that an instance of the HTTP client object can be automatically injected into the constructor of our webhook controller class. Let's open the file named handlebd-data-webhook.cs, which denotes our controller class. Let's type CTOR, then press the tab key to create our constructor in the handlebd-data-webhook class. Let's include a HTTP client parameter within the constructor of the handlebd-data-webhook class like this. Let's place our mouse pointers over the HTTP client parameter and press Ctrl- to invoke the relevant context menu within Visual Studio. Then let's select Create and Assign Field HTTP Client. So now when an instance of an object based on the handle BD data webhook class is created in memory, an instance of the HTTP client object will be automatically injected into the handle BD data webhook object at runtime through its constructor. So we are leveraging .NET's built-in dependency injection system here. We have just created a member variable that will reference the injected HTTP client so that we can reference the HTTP client from anywhere within the handle BD data webhook class. So let's create a private method that doesn't return a value called prepare HTTP client header. Let's copy and paste the code from the test scraper console app that sets up the header for the HTTP client object. Note that this code includes the code where the relevant BrightData security token is placed within the HTTP header. Let's precede HTTP client with the this keyword so that it is clear that our HTTP client member variable is being referenced here within our code. Let's create a method named getDataset from BrightData. This method will use async task, so it appropriately includes the async keyword in the method definition, and the return type, which is dynamic, is passed to the generic task type. So within the getDataset from BrightData method, let's firstly include a call to the prepare HTTP client header method in order to include relevant header information within our HTTP request to the BrightData platform. So let's go to the BrightData platform, navigate to the My Scrapers tab, and click the three dots next to the TIOBE 2 scraper list item. Then let's select the Initiate by API menu option. So within the text area here, we want to copy the relevant URI that denotes the endpoint of where we are able to get the result of a particular run of the TIOBE 2 scraper. So let's copy this URI to our clipboards and paste it within our getDataset from BrightData method. Let's comment it out. We'll use this within our code in just a bit. We need the job ID, or the ID pertaining to a specific run of the TIOBE 2 scraper, so we need to pass in the data received from BrightData from our webhook to our getDataset from BrightData method. So let's include a parameter within the getDataset from BrightData method that is of the dynamic type, and let's name it dynamic object. Why not? So this is what the ID looks like, which is the job ID that uniquely identifies a particular run of the TIOBE 2 scraper or collector. So we need to replace the collector underscore ID placeholder within this URL with the job ID, which will be in the ID field passed to us from BrightData. So let's build the URI appropriately. Let's create a variable named requestURI, and let's assign it part of the URI we copied from the BrightData platform a bit earlier. Let's set the parameter named ID within the URI to the ID of the dynamic object argument, which contains the relevant data passed to our webhook from BrightData. Let's use the getAsync method on the HTTP client object to return the relevant result of the collection or scraping operation performed by our TIOBE 2 scraper. Within the URI, we must set the ID parameter to the ID pertaining to the relevant scraping operation, i.e. the job ID, to the relevant ID passed to us from BrightData. Let's write out the status code from the response object returned to us. So let's implement an if statement to check if our GET request returns a response with a status code of 200 or OK. So our if condition checks the isSuccess status code Boolean value on the response object for this purpose. So if the isSuccess status code value is true, this means the response to our GET request has returned a status of 200 or OK. Let's convert the result into a JSON string using the readAsString async method. Let's write code to deserialize the JSON string into an object. Then we can write out the object to the console screen. Then let's return the object that wraps, as it were, the JSON data returned to us from BrightData to the calling code. Let's go to the post method and call our getDataset from BrightData method. Let's write the returned object out here rather than from within the getDataset from BrightData method. Okay, so let's run our webhook. Let's run the test scraper console app to kick off, as it were, the TIOBE 2 scraper. Great, it has kicked off the process successfully, and an OK response has been returned from BrightData. Okay, you can see on the BrightData platform that our scraper is running. So let's go to the output window of our webhook and wait for the results to be printed to the console screen. And you can see here the response from BrightData is status, collecting, message, job is not yet finished. So this means the data won't always be ready on the first call from our webhook to the BrightData platform. So we need to implement some kind of code that continuously calls the BrightData platform until the results are returned. I actually found the best solution to this was to create a background service that calls the relevant BrightData endpoint every 5 seconds. Usually on the second call, the results are ready and the results of our scraper are returned from BrightData to our webhook. So the next step is to set up a background service. Let's firstly create a folder within the Solution Explorer window. Let's name our new folder Background Services. Within the Background Services folder, let's create a class named FetchDataBackgroundService.cs. Let's go to the handle BD data webhook class and remove this code, because we want this code to be called from within our background service and not directly from within our webhook post action method. Let's go back to the fetch data background service class and let's make this class inherit from the background service abstract class. Select background service and press Ctrl Dot to invoke the relevant context menu and select Implement Abstract Class. And the method stub for a method named ExecuteAsync is created. So we are, in effect, through the inheritance and implementation of the background service abstract class, turning the fetch data background service class into a background service. Let's include the async keyword within the ExecuteAsync method definition. Let's instantiate an object of type periodic timer and pass in an appropriate value to the periodic timer class's constructor so that the background service executes every 5 seconds. So this means that code that we'll create within the execute async method will be called every 5 seconds in the background. Let's create an appropriate while loop to implement this functionality. Let's create a private async method named processDatasetAsync. Let's add basic code to output the name of the method to the console screen. Let's call the processDatasetAsync method from within the while loop. So let's open the program.cs file and add our background service to the services collection like this. So in this case, we must use the add singleton method to add our background service to the services collection. In order to run our background service in the background, we need to use the add hosted service method like this. So let's see what happens when we run our webhook. We should see the method name processDatasetAsync outputted to the console screen every 5 seconds. Oops, that certainly does not look like every 5 seconds. So something has gone horribly wrong. Let's investigate. Oops, there's the problem from microseconds. So it's currently printing processDatasetAsync to the console screen every 5 microseconds. So let's change from microseconds to from milliseconds here. And let's run the code again. And that now looks correct. It is printing processDatasetAsync to the console screen every 5 seconds. Great. So I want to control when code within the execute async method is called using a Boolean value. So let's create a private Boolean member variable named isEnabled and let's initialize it to false. Then within the execute async method, let's add an if condition that only runs the processDatasetAsync method when the isEnabled variable is set to true. Let's run the code. Great, the processDatasetAsync method name is no longer printed to the screen because isEnabled is false. Let's create a public method named initializeBackgroundService. Let's include a parameter within the initializeBackgroundService method named fetchDatasetID. Let's create a member variable of the same name. Let's assign the value that will be passed into the fetchDatasetID parameter to the member variable we have just created. That also has been given the name fetchDatasetID. So note how we use the this keyword here so that it is easy to distinguish between the relevant method parameter from its counterpart member variable. So within the initializeBackgroundService method, let's set the isEnabled Boolean variable to true. Let's write to the console screen that the background service has been enabled. Let's create a constructor by typing CTOR and then pressing the tab key. Let's include a parameter named factory that is of type iServiceScopeFactory. Let's create a member variable of the same name, i.e. factory, as well as the code that assigns the passed-in value to the member variable. We can do this automatically through Visual Studio by hovering our mouse pointer over the relevant parameter and pressing Ctrl-Dot, then selecting the Create and Assign Field Factory menu option. So within the process dataset async method, let's write code to extract the HTTP client object from the service collection. So instead of using dependency injection to get an instance of the HTTP object, we are doing this manually by using the async service scope object. Let's go back to the handle BD data WebHook class and cut the prepare HTTP client header method and the get dataset from BrightData method. Then let's paste these methods within our fetch data background service class. Let's modify the get dataset from BrightData method so that it includes one parameter that is of type HTTP client, like this. Let's remove the this keyword here. Let's modify the definition of the prepare HTTP client header method by including a parameter of type HTTP client, like this. Then let's make sure that when we are calling the prepare HTTP client header method from within the get data set from BrightData method, that we are passing in the HTTP client object. Let's remove the this keyword from here and from here. And within the get dataset from BrightData method, we have a red squiggly line. So let's replace the code dynamicObject.id with the member variable fetch dataset ID. And note the inclusion of the this keyword and the dot preceding the member variable name. The this keyword makes it clear that the fetch dataset ID variable is a member variable. So it's a member of the object that is instantiated from the relevant class. Then within the process dataset async method, let's make a call to the get dataset from BrightData method and pass in the HTTP client object that the preceding line of code has retrieved from the services collection. Then let's write out the JSON data returned from our call to the relevant BrightData endpoint. Let's go back to the handle BD data WebHook class. Let's pass in the singleton object derived from the fetch data background service class into the constructor of the handle BD data WebHook class. If you'll recall, earlier we included a HTTP client parameter here so that an instance of the HTTP client object would be passed into our WebHook controller class via dependency injection at runtime. We are now handling the retrieval of the HTTP client object from the services collection manually through code and not via dependency injection. So we are manually retrieving the HTTP client object from the services collection within our fetch data background service class. So instead of passing in a HTTP client object via dependency injection, we are passing in the instance of the fetch data background service object via dependency injection here. This is so that we can initialize the background service by calling the initialize background service method on the fetch data background service object. This is why we created the isEnabled Boolean member variable in the fetch data background service class and initialized it to false. We did this because we don't want to automatically start the background service. We only want the background service started when the webhook is called by BrightData. Then once our processing code has completed, we can set the isEnabled variable to false again, which means the background service will cease to call our code every 5 seconds. So we only want the background service to run the code that calls BrightData to retrieve the relevant data set, and subsequently our code then processes the data when necessary. So let's create a member variable of the same name as the fetch data background service parameter through Visual Studio like this. So you can see that when the constructor is called, that our fetch data background service member variable is assigned the fetch data background service object that will be passed into our webhook controller class at runtime via dependency injection. So within the post-action method, let's call the initialize background service method on the fetch data background service object. Let's create an if statement so that the initialize background service method is only invoked if the dynamic object variable is not null, meaning that our webhook has received a data notification from BrightData. We only want to initialize the background service when BrightData sends our webhook a data notification. The initialize background service method requires that an ID of the relevant scraper job is passed into it as an argument. So let's create a new variable named fetchDatasetID and assign it the value of the ID property contained within the data sent to our webhook from BrightData. So let's pass the fetchDatasetID as an argument into the initialize background service method. This ID value is the unique identifier for the scraping operation that has just been run on the BrightData platform. Our code within the fetch data background service class needs this ID value in order to build the appropriate URI that needs to be called in order for an appropriate HTTP GET request to be made to the BrightData platform in order to receive the relevant scraper results. So the next block of code that we'll write gets a little bit untidy, but we'll neaten up the code a bit later. So for now, just follow along and you'll get an idea of why this code needs to be in place as we progress. When the data is passed from BrightData to our webhook, we are converting the request stream to a string, and this string contains JSON data. We are using Newtonsoft to deserialize this JSON string into an object. Although this object is wrapped in a C# dynamic type, under the hood, it is a Newtonsoft object. Based on my analysis of the data returned from BrightData, the JSON data can either be an array, i.e. wrapped in square brackets, or an object, i.e. the JSON is wrapped in curly brackets. So the parent container of the JSON data can either be an array, denoted by square brackets, or an object denoted by curly brackets. So when Newtonsoft deserializes the data, the converted object will either be of type newtonsoft.json.link.jobject or of type newtonsoft.json.link.jarray. So we can use reflection to check what the underlying object's type is through this if statement. So let's go to the fetch data background service class, and within the process dataset async method, let's write the relevant if statement that uses reflection to evaluate the underlying type of the data sent to our webhook from BrightData. This will inform our code, as it were, as to what action should be performed next. So this if condition evaluates if the underlying object is of type newtonsoft.json.link.jobject. So my analysis of the data told me that if the underlying object is of type newtonsoft.json.link.jobject, this means that the dataset is not yet ready on the BrightData platform. To confirm this, we can create a nested if statement that checks the status of the relevant scraping operation returned from BrightData. So with this nested if condition, let's first check to see if the status property exists within the data sent to our webhook from BrightData. We can use the contains key method for this purpose. So if the status property is set to collecting or the status property is set to building, this means the dataset is not yet ready. So if this condition is true, let's write out to the console screen that the data is not yet ready. So at this point, our code will of course not process any data because no data is available yet. And the isEnabled member variable will remain set to true, which means in another 5 seconds, our background service code will make another appropriate GET request to BrightData. If, however, the underlying object is of type newtonsoft.json.link.jarray, this means that our dataset has been returned and we can now process the data, which of course means saving the data to our database. So the array result that we want to retrieve can be found at this point within the JSON data returned to us as a result of the relevant TIOBE2 scraping job. So let's assign a variable of type JArray to the results that we wish to retrieve. We can then, using link, project the raw data within the JArray into a strongly typed model that we can create. So the strongly typed model is just a plain old C# class that we'll create. So let's create the relevant model to house our data. Let's create a public class named TIOBE model. Let's create a public property of type integer and name the property rank order. Let's create a public property of type string and name this property language name. Let's create a public property of type string and name this property image path. We can then write link code to project the dynamic object containing the raw JSON data sent to us from BrightData into a collection of objects derived from our model, which is a strongly typed C# class. So once we are past this point, the data will be much easier to handle because the data will now be housed within a collection of strongly typed C# objects. So we are dynamically converting the properties in the raw data into their counterpart C# types. Then we can write C# code to traverse the collection of strongly typed C# objects and appropriately write out their properties to the console screen. Then let's set the isEnabled Boolean variable to false. So by setting the isEnabled variable to false, this means our code that makes the relevant GET request to the BrightData platform in order to obtain results of the last scraping operation will no longer be run every 5 seconds by our background service. This is because at this point, the relevant data has been processed. Our data being processed is currently denoted by the scraped data results being outputted to the console screen. This code has been implemented just for testing purposes at this stage. The actual processing will involve saving the relevant scraped results to our own SQL Server Database table. This is code that we'll be writing soon. So we must also include the explicit casting of this data into the JArray data type. So let's run our webhook. Let's kick off our TIOBE2 scraper by running our test scraper console app. Great! If we look at the Runs tab for the TIOBE 2 scraper, we can see that it is scraping as expected. So now, if we look at the output window for our webhook, oh, there seems to be a problem. Our data should certainly have printed to the output screen by now. Let's investigate what's going on. Oh, and it is a silly mistake here. We need to include the await keyword because the get dataset from BrightData method is an async method. So let's run the webhook again. Let's kick off the TIOBE 2 scraper. Let's go to the BrightData platform and confirm that our TIOBE 2 scraper is scraping. Great, it is definitely scraping. Then let's see what our webhook outputs. Excellent. So we are now receiving a notification from BrightData once our scraper has finished scraping. And look at that, there is our data printed to the console screen. Our background service is initiated and calling the relevant BrightData endpoint every 5 seconds in order to retrieve the relevant dataset, i.e. the result of the relevant scraping operation. Once the dataset is ready, we are, using LINK, projecting the dynamic object that houses the raw JSON data sent to us from BrightData into a collection of strongly typed objects. We are then writing out the data to the output screen in an easy-to-understand, meaningful way. We are then disabling the background service so that the relevant code is no longer run every 5 seconds. Great! So by outputting the relevant data to the output screen, this is substituting the actual processing of the data, which we'll create in a bit. When I say the processing of the data, this simply means we are taking the data sent to us from BrightData or retrieved from BrightData and saving it to our database. Okay, so great. We are now receiving the results accumulated through our scraping operation from BrightData. BrightData is first sending a notification to our webhook when the scraper has finished scraping. Within the notification data is included a job ID that we can subsequently use to call an endpoint on the BrightData platform. So we are using the HTTP client component to call the relevant endpoint, and if successful, the returned data contains either a message stating that the data is not yet ready, and this is due to the data accumulation process not yet being finalized. So the scraping status will be reflected in the data notification, which in this case will either be collecting or building. So our background service will keep calling the relevant endpoint until the result of the web crawl is returned. At the moment, we are, using LINK, projecting this data from the JSON data returned to us from the relevant endpoint into a strongly typed collection of objects that are derived from a strongly typed C# class, which is our custom created model that represents data from one row from the TIOBE index. So now the next step is we want to capture this data within our own SQL Server Database table. So to do this, we are going to firstly remove the current model that we created for testing purposes and create a new file for our model that represents the schema for an item in the TIOBE index. We'll then create a DB context class that will allow us to leverage Entity Framework Core in order to map our objects derived from the models we'll create to counterpart SQL Server Database tables. We'll then be able to interact with the SQL Server Database tables through Entity Framework Core. Before we create the functionality to insert the TIOBE index data scraped from the TIOBE index into the relevant SQL Server Database table, we'll firstly create the database through Entity Framework Core database migration functionality. Don't worry if this is not clear to you at the moment. As we progress through this part of the course, the relevant concepts will become clearer to you. Okay, so the first step is to create a model for representing a row of data scraped from the TIOBE index. So if we look here within SQL Server Management Studio, I have already created the database for storing the data accumulated by the scrapers that we are going to create during this course. Here is the table for storing the data scraped from the TIOBE index. And we already have data in this table, which has been captured as a result of code that I ran off screen. So code that scraped the TIOBE index, and then code within the webhook that saved the relevant data to the database table. So I'm not going to use this particular database moving forward. I'll create a new database with you using EF Core Data Migrations. This is just so that you can see what one of the tables will look like with data in it. So let's firstly go to Visual Studio, where we have our Web API project loaded, the project that houses our webhook code. Within the Solution Explorer window, let's create a folder named Entities. We'll use this folder to store the classes that represent our model classes. These particular models will be used by Entity Framework Core to map the objects derived from them to their counterpart SQL Server tables. Let's right-click on the Entities folder and create a C# class. Let's name this class TIOBE Ranked Language. Each instance of this class represents a row in the TIOBE index, which of course denotes a particular ranked programming language. Within this class, let's create a property of type integer named ID. A quick way to create a property in Visual Studio is to type prop, then press the tab key, and then we can modify each of the property definition elements. Once a modification is complete, we can press the tab key to progress to the next property definition element, and then subsequently make the relevant modification. Let's create a new integer property named rank order. So for example, Python is ranked number 1, C# is ranked number 5, so this property will store the relevant TIOBE index ranking value. Let's just make sure this D in ID is in lowercase here. Let's create a new property of type string, which is named language name. So for example, for the number 1 ranked language, Python will be stored in this property. For the number 5 ranked programming language, C# will be stored in this property, and so on. Note the question mark symbol added to the end of the string definition here. When we run our migration to generate the associated SQL Server Database table, this field in the relevant database table will be nullable, so it will be able to accept null values in the relevant field. And lastly, let's create a property of type string that stores the relative path for the image that represents the relevant programming language. Note that this property is also nullable. This rule is established through the inclusion of the question mark symbol placed after the string data type definition here. So the next step is to create the DB context class so that we can leverage Entity Framework Core. So let's first create a folder within the Solution Explorer window. And name it data. Let's add a C# class to this folder, and let's name this class Scrape Capture DB Context. So let's make our class inherit from the DB context class, which is an Entity Framework Core class. So you can see that DB context has a red squiggly line under it. This is caused because we don't yet have the relevant Entity Framework Core NuGet package installed for our .NET Web API project. So to install Entity Framework Core, let's right-click the Dependencies node here and select the Manage NuGet Packages ... menu option. In the search here, let's type in Entity Framework Core.SQL. And this is the package we want to install, Entity Framework Core.SQL Server. So let's install this package, like this. And now, when we make our class inherit from DB context, once we have brought in the Microsoft.EntityFramework core namespace, no red squiggly line is present. Let's create a constructor for our class. A quick way to create a constructor in Visual Studio is to type CTOR and then press the tab key. So we must include a parameter within the constructor which is of type dbContextOptions. Let's name this parameter options. Then we can pass down the options passed to our scrape capture dbContext class to the dbContext base class using the base keyword like this. So we need to include the dbContextOptions parameter and pass it down to the base class so that we can appropriately integrate our code with Entity Framework Core. So the next step is very important, and this is where we map our model classes to the relevant SQL Server Database tables. So to map our TIOBE ranked language model to the soon-to-be-created SQL Server table, we create a public property of generic type dbSet, and we pass the TIOBE ranked language type as a type argument to the generic dbSet type like this. And let's name this property TIOBE ranked languages. So you can think of it like this. Multiple entities of type TIOBE ranked language will be stored in the TIOBE ranked languages table. So in order to run our Entity Framework Core migration commands, we need to include two more NuGet packages. So let's first install the Microsoft.EntityFramework.design NuGet package. Great. Let's also install the Microsoft.EntityFramework Core.tools NuGet package. Great. So now let's establish the connection string that will connect our code within the Web API project to our SQL Server database. So to do this, let's first open the appsettings.json file within Visual Studio. Let's include the relevant configuration setting for our connection string. Let's create a new connection string property. Within the connection string JSON object representation, let's create a new property named scrape capture dbContext. Let's associate our connection string with the scrape capture dbContext property. Let's firstly set the value for the server parameter of our connection string. Note that your server value will be different to mine, so you should verify what the value for this parameter is within your SQL Server Management Studio UI. You can find the relevant server setting here. So if you are running your instance of SQL Server locally, you can precede this value with localhost, then 2 backslash characters like this. So then you can choose a database name for your database. I already have a database named Learn IT Resources DB, so I'm going to add 2 to the end of this database name so that a new database will be created called Learn IT Resources DB2 when I run my first EF core migration. So let's add trusted_connection equals to true within our connection string, which means that we don't need to include specific username and password credentials for our database within the connection string. We are basically saying here that the account used to log on to the operating system should be trusted and have access to the database. So this is fine for when we are testing our code locally. The last setting we need to include is trust server certificate equals true. If you use trust server certificate equals true in the connection string, the connection process skips the trust chain validation. In this case, the application connects even if the certificate can't be verified. We are using this setting to bypass the relevant security check when running our code locally. So we are including this setting here just for testing purposes. So now let's open up the program.cs class and add our DB context class into the services collection. This means that an instance of the scrape capture DB context class will be available to our controller class through dependency injection. I'll show you a bit later in the course how we are also able to manually retrieve an instance of the scrape capture DB context class from the services collection as opposed to using dependency injection. This is essential when using the scrape capture DB context object within our background service. So let's use the add DB context method to add the scrape capture DB context type to the services collection. And we must pass the scrape capture DB context type as a type argument to this generic add DB context method like this. Then let's configure our scrape capture DB context object to use SQL Server as the database management system type. Let's assign a new variable, the value of the connection string that we configured a little bit earlier in the app settings.json file. Then let's pass this variable to the use SQL Server method here. So now we are in a position to create our database and TIOBE ranked languages SQL Server database table by running an appropriate EF core database command. So let's first open the NuGet Package Manager console window like this. Let's run the appropriate add-migration command. So to do this, type add-migration here, and then include a sensible name for the migration. So I'm going to call my migration initial create. Then press the enter key. Great! So this command generates the migration code for creating our database and the TIOBE ranked languages database table. So the migration code is presented to us. In this class, there are two methods in the relevant migration class, one called up and the other called down. The code within the up method creates our database and the TIOBE ranked languages table within our SQL Server database. The code within the down method basically undoes the effects caused by running the code within the up method. So to run the code within the up method, we run the command within the NuGet Package Manager console window called update database. So let's run the update database command like this. So let's type update-database here and press the enter key. Oops, and we have a bit of an issue. Okay, so the connection string is not quite right. I included a setting here called Trusted Server Certificate. This setting should be Trust Server Certificate. So let's change this setting appropriately. Now let's run the update-database command again. Excellent! And our database named Learn IT Resources DB2 has been created within our local instance of SQL Server, and the table named TIOBE Ranked Languages has been created within the Learn IT Resources DB2 database. The TIOBE Ranked Languages table schema is of course based on the class which we named TIOBE Ranked Language. Great! So now that we have created the infrastructure for leveraging EF Core within our webhook, we are in a position to create the code for capturing the results of the TIOBE2 collector or scraper within our SQL Server database. So let's write the code for this. We already have code in place that projects the raw JSON data from a dynamic object into a collection of strongly typed C# objects. We created this code rather crudely just to get the basics of the concept working. So we were able to do this as well as write the scraped data to the output window of our Web API project. Now let's neaten up the code. To begin with, let's create an abstract class and let's name it DataHandler. We'll then create a class representing the relevant functionality to handle the TIOBE index data that will inherit from the DataHandler abstract class. In fact, we'll create a class to handle the data for each of the 3 scrapers that we create in this course. Each of these classes will inherit from the DataHandler abstract class. By designing the code in this way, we are in effect able to consolidate code that is common to data handling for each of the scrapers within the DataHandler abstract class. Each of the data scrapers will have a class that inherits from the DataHandler abstract class, where we can create code that pertains to functionality only relevant to the associated scraper, i.e., to handle the data pertaining to a specific scraper. So let's first create a folder named Data Handlers. Before we create the DataHandler abstract class, let's firstly create code that only pertains to the TIOBE index scraper. Once we progress to the data handling functionality pertaining to other scrapers, we'll then create the DataHandler abstract class to consolidate common functionality for all DataHandler classes within this class. Remember, each of the DataHandler classes pertaining to their counterpart scrapers will inherit from the DataHandler abstract class. We'll create the DataHandler abstract class a little bit later. For now, let's create code to capture the data for the TIOBE index into our SQL Server Database table named TIOBE Ranked Languages. So let's firstly create a C# class named TIOBE DataHandler within the DataHandlers folder. Firstly, we want to create a method that returns the J array. This is a Newtonsoft type that contains the actual array that denotes the scraped TIOBE index result. So by result, I mean the data scraped from the HTML table on the TIOBE web page here. Let's call the method getDataToProcess. So this method simply returns the data derived from the new JSON data returned from BrightData, explicitly typecasts the data into a J array, which is a Newtonsoft data type, and returns the data as a J array to the calling code. So this path, as it were, to the relevant collection of TIOBE ranked language data is specific to the TIOBE scraped result. As we progress with the creation of the relevant data handling code, the overarching design pattern used here will become clearer. Let's create a constructor for our TIOBE data handler class. Let's include a parameter within the TIOBE data handler constructor, which is of type scrapeCaptureDBContext. Let's set a member variable of the same name of this parameter to the value that will be injected via .NET's dependency injection system into this constructor at runtime. Let's create a method named prepareData. The prepareData method accepts one argument of type JArray and does not return a value. Let's create a member variable, which is a list that is strongly typed with our TIOBE ranked language user-defined type. Then within the prepareData method, we are creating the code that uses LINQ to project the collection of rows scraped from the TIOBE index into a collection of strongly typed objects derived from our TIOBE ranked language model, which is just a user-defined C# class. So you'll notice that there are green squiggly lines under these lines of code here. This is the C# compiler warning us that these values stored within the raw data retrieved from the BrightData platform may be null, which can cause a runtime error. By including the exclamation mark symbol at the end of each of these values, we are telling the C# compiler to ignore this so that the green squiggly lines disappear. So we are telling this to the C# compiler, as it were, because we are confident that the relevant values will not be null and therefore will not cause a runtime error to occur. Then let's set the member variable we just created named ranked languages to the newly projected strongly typed collection of TIOBE index scraped results. Let's create a method that actually adds the data to the SQL Server Database. Let's call this method addData. And this method simply adds the collection encapsulated within the ranked languages list to the database by leveraging EF-Core's addRange async method and subsequently EF-Core's saveChangesAsync method. And notice that we are passing in the member variable that stores the strongly typed list of TIOBE ranked language data to the addRange async method. So we are leveraging EF-Core functionality to save the relevant list items as counterpart rows within our TIOBE ranked languages SQL Server database table. So if the code reaches this point, it means that our data has been successfully saved to our database. So let's return true from the addData method here. If, however, the code gets to this point, it means that our saving operation has failed. So let's return false here. So before we add the data to the database, we want to make sure that the relevant SQL Server table is empty. So let's create a method named removeData. So we are able to pass raw transact SQL code to EF-Core through the execute SQL raw async method. So let's use this method to empty the relevant SQL Server database table. So to do this, we can use the truncate SQL command like this. Great, so let's go to the code within our background service code and appropriately call the methods of the TIOBE DataHandler class in order to add the data scraped from the TIOBE index into the relevant SQL Server database table. Let's comment out this code here. Let's create a new instance of the TIOBE DataHandler class. We need to pass an instance of the scrape capture DB context class into the TIOBE DataHandler constructor. So let's manually retrieve the instance of the scrape capture DB context class from the services collection using the async service scope object like this. So rather than using dependency injection to get an instance of the scrape capture DB context class, we are manually retrieving the instance through the async service scope object like this. So I'm just going to cut this code here and move it just above the code that instantiates the TIOBE DataHandler class. Then we can pass the relevant instance of the scrape capture DB context class into the constructor of the TIOBE DataHandler class here in the code that instantiates the TIOBE DataHandler class. Then we can call the relevant methods on the TIOBE DataHandler object in order to add the scraped TIOBE index data into the relevant SQL Server database table. So let's firstly appropriately call the getDataToProcess method in order to get the relevant collection of TIOBE data from the dynamic object used to encapsulate the raw JSON data returned from BrightData. And we must pass the raw scraped data, as it were, retrieved from the BrightData platform into the getDataToProcess method. Then let's call the prepareData method. This method takes the data now explicitly converted into the JArray type by the getDataToProcess method and projects each item within the relevant JArray collection into a collection of strongly typed TIOBE ranked language data. Then let's call the removeData method to ensure that the TIOBE ranked languages SQL Server database table is empty before we add the data. Lastly, let's call the add data method, which will use EF-core to add the collection of TIOBE ranked language data into the TIOBE ranked languages SQL Server database table. Let's write out the relevant status information to the console screen. And we are now ready to test our TIOBE index data capturing code. So let's run the Web API project to make sure that our webhook is listening. Let's run the test scraper console app to kick off, as it were, the process of scraping the TIOBE index on the BrightData platform. Great, so we can see on the BrightData platform that our TIOBE2 scraper is now scraping the TIOBE index. Let's go to the output console window for our Web API project to see the status outputted to the window. Hopefully the status output will indicate that our data has been successfully captured within our TIOBE ranked languages SQL Server database table. Oh wow, and that's looking good. Let's look at our TIOBE ranked languages SQL Server database table. We have just scraped the TIOBE index and captured the data within our SQL Server database table. That is truly awesome. Okay, so now that we have captured the scraped data for the TIOBE index within our SQL Server table, let's create a Blazor application in order to display our captured data in an aesthetically pleasing way in a web browser to our users. So let's fire up another instance of Visual Studio. Let's create a new project based on the Blazor web app project template. Note that the Blazor web app project template is only available on .NET 8. Let's name our new Blazor project Scraper Data Display. Let's create a local folder in which we'll save our Blazor application project files. Let's select the newly created folder for the location field. And let's press the next button. And let's just keep the default values here. So let's click the Create button to create our project. Let's run our project. And you can see that right out of the box, we have some functionality already created for us. But we don't want either the weather forecast or counter functionality. No, we want to display the TIOBE index on our own web page. So, to access the data within our SQL Server database, we need to set up the infrastructure so that we can use Entity Framework Core to communicate with our SQL Server database. We only want to retrieve data from the database from within our Blazor app, so we don't need to update data within the database or add data to the database. We only want to read data from the database through our Blazor web app. The process of setting up the code so that we can leverage EF-core to read our data from the database is very much the same as the code we created for this purpose within our Web API project. So firstly, let's create a folder named Entities. Let's create a model that represents the TIOBE index data. We can literally just copy the relevant properties from the equivalent class that we created in our Web API project and paste them into the TIOBE ranked language class that we have created within our Blazor project. Next, let's create a folder to house our DB context class. So let's create a folder named Data. Let's create a class named, you guessed it, Scrape Capture DB Context. So this class is identical to the equivalent DB context class that we created in our Web API project. So we can just copy and paste the relevant code from our Web API project into our Blazor project. But firstly, let's install the Microsoft.EntityFramework Core.SQL Server NuGet package. So let's copy and paste the code from our Web API project into our Blazor project for our Scrape Capture DB Context class. Let's make sure that the Scrape Capture DB Context class inherits from the DB Context class. Let's copy the connection string from the app-settings.json file in the Web API project to the app-settings.json file within our Blazor project. Let's add the Scrape Capture DB Context type to the services collection within the program.cs file in exactly the same way as we did in the Web API project. Let's create a folder named Services. Let's create an interface within this Services folder named TIOBE Service. Let's include an appropriate definition for a method named getTIOBE-ranked-languages. So the implementation of this method will simply involve retrieving all the data stored within the TIOBE-ranked-languages SQL Server Database table. So let's create a class named TIOBE Service. And let's make this class implement the TIOBE service interface like this. Let's create a constructor within our class here and include a parameter of the Scrape Capture DB context type, so that an instance of the Scrape Capture DB context type will be passed into this class at runtime through dependency injection. Then we can reference the Scrape Capture DB context instance from within the constructor using a member variable. Note how the member variable within the constructor is preceded by this dot. This means that the relevant variable is a member of the object in which it resides. So let's implement the code for the getTIOBE-ranked-languages method. So let's use link to query the TIOBE-ranked-languages SQL Server Database table with this code. So this method returns all of the rows with the TIOBE-ranked-languages SQL Server Database table in the form of a strongly typed list that is strongly typed with our TIOBE-ranked-language user-defined type. So the return type of the getTIOBE-ranked-languages method is currently not correct. We want to return a strongly typed list that is strongly typed with the TIOBE-ranked-language type from the getTIOBE-ranked-languages method. So let's fix this accordingly. You can see now we have a red squiggly line under TIOBE service. This is because our TIOBE service interface needs to be updated. where the definition of the getTIOBE ranked languages method definition is changed so that the return type is a strongly typed list that is strongly typed with the TIOBE ranked language user-defined type. Now, if we go back to the TIOBE service class, we can see that there is no longer a red squiggly line. Great. So the next step is to create a Razor component within the Pages folder and let's name this Razor component TIOBEindex.razor. Let's add a directive so that the render mode is interactive server. This in effect means that this web page will have a persistent signal R connection maintained between server and client. So this web page works in exactly the same way that a Blazor server Razor component works. Note that we could in fact use SSR, server-side rendering, and streaming rendering here because we won't be using any interactive functionality in this web page. I don't want to get too deep into leveraging different render modes in this Blazor app. So I've chosen to consistently use interactive server for the Razor components in this application. We can discuss render modes in more detail in a subsequent video. Let's include a using directive so that we are bringing in, as it were, the scraper data display.entities namespace. Let's bring in the scraper data display.services namespace. Let's use the @page directive to implement the root for this Razor component, which is /TIOBE index. So let's write the code needed to inject an object instance of the TIOBE service class into this Razor component. So we use the @inject directive to do this. Within the @code section of our Razor component, let's create a private variable named TIOBE ranked languages that will be used to store the TIOBE index data retrieved from the database as a list. Let's create a const string to store the base URL of the TIOBE index website. You'll see a bit later that this value is significant for presenting the images representing the relevant languages on our web page. Within the @code section of our Razor component, let's include the Blazor lifecycle hook that runs when the Razor component is loaded. So let's add an override for the onInitialized async method. An easy way to do this through Visual Studio is to type the word override, then press the spacebar key. We are now presented with a list of items. So let's choose the onInitialized async method, and once we have selected this option, the definition for our onInitialized async method is created for us. We must include the async keyword within the definition for the onInitialized async event handler method. The code within this lifecycle hook event handler method will run when our component is first loaded. So this means that we can create code within this method that will run when our Razor component is loaded. So let's call the getTIOBE ranked languages method on the object instance of the TIOBE service class passed into the Razor component through dependency injection. And let's assign its returned value to the TIOBE ranked languages variable. So now let's write the markup code. So let's create a div tag to encapsulate our list of TIOBE ranked languages. Let's output the relevant languages by looping through the data stored within the TIOBE ranked languages list. So we are using a for each statement to do this. Then let's write code to output the rank order property the image representing the ranked language. See how we are concatenating the base URL for the TIOBE index website with the relative path stored within our TIOBE ranked languages SQL Server Database in order to include the relevant language images on our web page. And then lastly, we want to output the name of the ranked language. Notice how we are using basic Bootstrap 5 classes to style the elements included in our markup code. Let's include a basic loading indicator on our web page that will be displayed to the user while the TIOBE ranked languages list is null, i.e. while the relevant data has not yet been retrieved from the database. So, if the TIOBE ranked languages variable is null, output the loading indicator, else output the data in a stylized way to the user. So the last thing we need to do before we run our code is make sure that our users can access our new Razor component from within the menu bar presented to the user on the left bar in the user's browser window. So to do this, let's open the file named navmenu.razor. Let's duplicate this menu item here. Then let's change this href attribute so that our new menu item points to our Razor component. Let's change the menu name that will be presented to the user to TIOBE index. Let's run the code. Oops, and something has gone wrong. What have I done wrong? As always, I've forgotten to register a service class. So let's open the program.cs file and include the appropriate code to register the TIOBE service class for dependency injection, like this. Let's run the code again. Let's click on the TIOBE index menu item. Awesome. So we are now displaying the data scraped from the TIOBE index on a web page created within our own Blazor application. So like magic, we have our own TIOBE index within our website. Excellent. Okay, so we have now scraped the TIOBE index and captured the data in our SQL Server Database. We have written code for a Blazor web app that displays the top 20 ranked programming languages in an aesthetically pleasing style on our web page within our Blazor web app. That's great, but why not just go to the TIOBE index website to get the same information? The point of our application is to provide information on resources on the most popular programming languages to our users so that they can use the relevant resources to learn how to program using one or many of the programming languages ranked in the TIOBE index. So in this section of the course, we are going to scrape the world-renowned Amazon website for textbooks pertaining to each of the languages that we captured from the TIOBE index. So let's go to the BrightData platform. You can see here that I have already created the scraping code to scrape Amazon for the relevant textbook information. So let's look at the Amazon scraping code that I've created using the BrightData IDE. This is the prototype code, if you like, that I created in preparation for this course. We'll create our own Amazon scraper in just a bit, named Amazon 2. So in the interaction code section, here we can see that we are first navigating to the URL of the web page that we want to scrape. This URL that is passed to the BrightData IDE's built-in navigate method not only navigates to the Amazon website, but also contains search criteria. This search criteria conveys information to Amazon about what products should be displayed on the web page that will be scraped by our code. So our code within the BrightData IDE, our Amazon scraper code, will subsequently target information about the products that appear in the relevant Amazon search results and return the information to our webhook. Of course, then our webhook will capture the relevant information about the textbooks presented in the Amazon search results within our own SQL Server Database. We will then create the code within our Blazor web app to display the data in an aesthetically pleasing style to the user. So to understand the parameters within the URL passed to the navigate method, let's take a closer look at the URL. So within the URL, we have the I parameter that is set to a value of stripbooks-intl-ship. This filters the Amazon search results based on the type of product we want returned in the Amazon search results. So here in the URL, the I parameter is set to stripbooks- intl-ship, which basically means we only want books to be returned within the relevant Amazon search results. Then if we look here, the BrightData IDE's input object is used to capture a value passed in by calling code. So passed into the scraper by calling code. So the passed in argument is named search. So we have in the code input.search. This input.search parameter value will be one of the programming languages that we have captured from within the TIOBE index. So for example, the input.search value here included within the relevant URL could be Python, or for example, Java or C#. These are the programming languages that we have captured from the TIOBE index. The broader system for our application will involve this scraper being triggered for each programming language that we have captured from the TIOBE index. So each time this scraper is run, information for the relevant textbooks returned from the Amazon web page denoted by this URL will be captured within our SQL Server Database. So the code here denotes scraping textbook information for textbooks pertaining to one programming language contained within the TIOBE index. So once we have all the information for the TIOBE index captured within our SQL Server Database, our system will kick off our Amazon scraper 20 times, i.e. from the first ranked language to the last ranked language, and capture relevant textbook information pertaining to each programming language. So each time the Amazon scraper is triggered, a programming language will be passed into our Amazon scraper, and this parameter value is denoted by the input.search value included within the URL passed to the navigate method here. You can also see the word programming has been included after the input.search value within the URL. This is to further filter the search so that only relevant data is included in the Amazon search results. For example, if the programming language C is included for the K parameter in the URL, this could be highly ambiguous. So to be more specific, the K parameter value is augmented by the word programming. So in effect, in this case, C programming is included in the URL for the K parameter rather than just C. So to demonstrate what BrightData is doing behind the scenes, as it were, through the navigate built-in BrightData IDE method, let's manually navigate to the Amazon website and manually perform a search that will be automated by our system. It will be automated by our scraper. So to filter our search by book, we can select the books category here. Then we can type in our search criteria here within the search text box in the Amazon website here. So let's type in C# programming. So we are presented with pages of results pertaining to textbooks that are available to purchase from the Amazon website for C#. Note that for simplicity, I've limited this Amazon scraper code to only scrape one page of data, which is 16 textbooks. But we can scrape as many pages as we want to using our scraper. I'll explain how we are able to scrape the information from multiple pages later in this course. You can see in our code here that we have a built-in BrightData method named parse. When we call this method from within the interaction section, we are in effect calling the code within the parser section. Note that an object is returned from the parse method, and here we are assigning the value stored within a property of the object named products to a local variable also named products. This products property contains all the data pertaining to the Amazon products returned from the relevant Amazon search results. Please note that you don't have to worry about the details of the Amazon scraping code. You can simply copy the code from GitHub. So please copy the code from this file that denotes the interaction section and this file that contains code for the parser section. So copy the code from here and paste it into the interaction section, and copy the code from here and paste it into the parser section of your Amazon scraper. I just want to draw your attention to an issue that I encountered when testing the code that I created in preparation for this course. So, after my first attempt at writing the Amazon scraper, during testing I discovered when running the Amazon scraper using search criteria like C# or C++, that the results returned were not quite right. This problem was caused by including the literal sharp character when using C# as search criteria, or the literal plus character when using C++ as search criteria within the relevant Amazon search URL in code. So to fix this issue, I wrote this parse search param method that is called so that the sharp character is replaced with %23 and the plus character is replaced with %2b before the search criteria is added to the relevant Amazon search URL. So %23 represents the sharp character in hexadecimal, and %2b represents the plus character in hexadecimal. The literal plus and sharp characters have a special meaning when included inside a URL address in your browser, and therefore are not interpreted as a literal sharp character or a literal plus character. So for our purposes within the Amazon scraper, we need to escape this in our code by using the hexadecimal equivalents of these special characters when they are included in a URL address. Not knowing about BrightData's built-in solution to this issue at the time, I created a method named parse search param, which simply replaces the sharp character with %23 and the plus character with %2b. This did fix the issue, but is simply not the best solution. It is certainly not the cleanest way to resolve this issue. I later learned that a much cleaner solution to this issue is available when using the BrightData IDE. So let's go through how to properly add the relevant search criteria using BrightData's IDE. So firstly, let's remove the parse search param method. You won't have this method because I've already created the relevant fix in the relevant GitHub repository. Then let's remove all search criteria from the URL passed into the navigate method here. So the search criteria will be the input parameter, i.e. the parameter passed to the scraper, which in this case will be the programming language name. Then we are concatenating the programming language name with a space and then the literal text programming so that our search criteria is not ambiguous. Then rather than use the navigate method here like this, let's create a URL object like this. Now that we have a URL object, we can use built-in BrightData functionality to add the relevant search criteria to the Amazon search URL. So to add the programming language search criteria, let's type URL, which represents our newly created URL object, .searchparams.set. Then we can pass in the Amazon URL parameter name, which in this case will simply be the letter K, into the first parameter. And the value pertaining to the K parameter is our search criteria that contains the programming language name. So we pass in the search input variable to the second parameter. Then we need to add another parameter to our Amazon search URL, which is simply denoted by the letter I. And then the value associated with the letter I is the literal text stripbooks-intl-ship. This simply filters our Amazon search by the books product category. So if, for example, the programming language name C# is passed into our Amazon scraper from an external source, our code knows, as it were, to construct an Amazon search URL that will search for books on Amazon pertaining to the C# programming language. Once we have added the relevant Amazon search parameters using the URL.searchparams.set method, we can appropriately call BrightData's built-in navigate method in order to execute the relevant search on Amazon. So here we are adding the K parameter to the URL, which is set to a TIOBE index ranked programming language name that is concatenated with the literal text programming. And we are setting the Amazon search parameter denoted by the I character to the literal text stripbooks-intl-ship. The navigate method is then used to navigate to the Amazon website, and the parameters included in the URL contain the relevant Amazon search criteria. We can add a search parameter, which will add a search text box to the URI here so that we can include the appropriate search parameter when we preview the running of our scraper code. We can enter a particular programming language, for example C#, within the relevant text box. So as mentioned earlier, this is the collector or scraper that I created when testing the scraper code for the Amazon part of this course, as it were. Now let's go through the process of creating the Amazon scraper together. So I'm going to create a new tab within our browser and navigate to the BrightData platform. Let's go to the My Scrapers tab and create a new scraper like this. So here, let's choose the Start from Scratch option. In the interest of time, I'm just going to copy the code from the first Amazon scraper that I created and paste the code into the new scraper that I've just created. So I'm simply demonstrating broadly how to create the Amazon scraper, and we are not going to create the code together line by line like we did for the TIOBE scraper. The only difference in how you'll create your Amazon scraper and how I'm creating my Amazon scraper here is I'm copying the code from a scraper that I've already created on the BrightData platform off screen. This was done in preparation for this course. You, however, will need to copy the code for your Amazon scraper from GitHub. So, as discussed, you will need to copy the code for the interaction section from this file on GitHub and paste it into the interaction section within your BrightData IDE. You will also need to copy the code for the relevant parser section and paste it into the parser section on the BrightData IDE of your Amazon scraper. The code that I'm copying in the next step is the old code that includes the parse search param method. This code will work perfectly, but the updated code on GitHub is much cleaner. So the relevant GitHub repository includes the updated code that eliminates the need for the parse search param method. So in the interests of time, we won't create the code step by step. Please copy the code from the relevant GitHub files in order to create your Amazon scraper. So I'll copy the code from the interaction code section from the old Amazon scraper and paste it into the interaction code section of the new collector or scraper. And I'll do the same thing for the parser code section. As discussed, you will need to copy the code from the relevant files on GitHub at this URL. So we only have one collector stage for our Amazon scraper. This is because we are only going to scrape one page of results. If we were to scrape multiple pages of results, we could create a new stage within the IDE. I'll explain the concept of stages a little bit later. So I'm going to name this stage Get Amazon Search Results. So to test our scraper code, let's add an input parameter. To do this, we can click this Add Input Parameter button. In the field name field, let's type search. And the type of this search parameter is string. So let's select the string data type from the drop-down here. Then let's click the Add Another Input button here. We can then test our scraper by inputting a programming language. Let's type in Java and press the Preview button to test our code. And look at that! we have just scraped the desired data from Amazon for data pertaining to textbooks written about the Java programming language. We can take a closer look at each textbook result by clicking the eye icon that appears next to each result. That in this case denotes a textbook. We can download an individual JSON result, in this case pertaining to a specific textbook. Or we are able to download all the JSON results by pressing this button at the bottom right of the UI here. So let's download all of the JSON results by clicking this button here. Let's take a look at the JSON result in Visual Studio. So within Visual Studio, to format this JSON result, we can right-click the code editor like this and select Format Document. And this preview output denotes the JSON result that we'll retrieve from within our webhook. So later on within the webhook, we'll extract the relevant data from this JSON result and insert the relevant data appropriately into a table within our SQL Server Database, much like how we did for the TIOBE index scraped result or scraped data. So if we click on one of the URLs here, we can see one of the products that we have scraped from the Amazon website. So let's test our scraper code where C# is entered as search criteria. Great. And Python? Great. And now that we are happy with the test results, let's click the Finish Editing button here. So the code for our Amazon scraper has now been saved on the BrightData platform, and we will now be able to trigger our collector externally by calling a HTTP endpoint that has been created on the BrightData platform for this purpose. Let's go to My Scrapers and rename our new Amazon collector. I'm just going to name the new collector Amazon 2. I actually based this Amazon scraper on code created by another programmer / content creator named Sunny. Sunny has a popular YouTube channel. Please check out Sunny's YouTube channel here and please subscribe. He produces excellent content. So if we navigate to Sunny's GitHub repository, he has made this code available to the public. The difference between the code used in this course and Sunny's code is that Sunny's code is scraping multiple pages on Amazon. So his scraper is scraping multiple pages relating to a specific search result. I decided to create similar code to the code here that Sunny created, but only scrape the first page of the results. The only reason I did this is because I don't feel I need to scrape multiple pages in this demonstration. Because bear in mind, we are scraping a lot of data when you consider that we are scraping through all 20 of the programming languages ranked on the TIOBE index and scraping data for textbooks from Amazon pertaining to each of the ranked languages. If you, however, wanted to scrape multiple pages pertaining to a particular search result on Amazon, you can use Sunny's code here as a guideline. So I'll briefly show you how you can scrape multiple pages per search result. So to demonstrate this, I'll create a new collector. Note that this collector is for demonstration purposes and won't be a part of the application that we are creating in this course. We are only going to scrape one page for the results per language in our application. This is just to show you how you could extend the functionality of the scraper to scrape multiple pages of search results from Amazon. So we can copy Sunny's code here, where he has named the file step1_interaction_code.js and paste it into our interaction code section here. Then we can copy the code from the file named step1_parser_code.js into the parser code section of our scraper. So now this is where Sunny's code is fundamentally different from the code that we are creating in our Amazon scraper. If we look at the parser code here, this code is returning the number of pages of results to the interaction code section. By doing this, the code in the interaction section can loop through the pages of results, then call code that is included in another stage to return the parsed code captured for each page of results. So with each iteration of the loop, the next stage that we'll create in a bit is run. This second stage will contain the code for parsing the data captured for a particular page of results. So the first stage establishes how many pages of results should be traversed. The second stage actually parses the data for each of the pages returned from the relevant Amazon search. So essentially in the interaction section of the IDE, for the first stage, an appropriate URL is constructed for each page of results that this URL is navigated to by the next stage, where the relevant page is scraped, parsed, and ultimately the data is collected. So let's create the code for the next stage. So to create the code for the next stage for our scraper, we press the plus button here. Then we can copy Sunny's code from the relevant GitHub file, named step2_interaction_code.js, and paste it into the interaction code section of the IDE for our stage 2 code. And then we can do the same for the stage 2 parser code. And I hope that all makes sense. Basically, the code we are using in our application is a simplified version of Sunny's code, because I only wanted to scrape one page of data. But if you want to scrape multiple pages of results, please check out Sunny's code here. You can simply modify the code that we are creating in our application to include functionality for scraping more than one page of results. We are able to scrape multiple pages using the code by ultimately creating 2 stages for the collection process. Our scraper only involves one stage, and this has been deliberately done in the interests of simplicity. But I want you to be aware that you are able to scrape multiple pages of search results through creating 2 stages for the relevant scraper. So the next step is to test our Amazon scraper by creating the appropriate code within our test scraper console app and then running it to kick off our Amazon scraper. So let's open the test scraper console project within Visual Studio. Let's add a comment here that this endpoint pertains to the TIOBE index. And let's add another comment here to label our Amazon endpoint. These HTTP endpoints are of course the endpoints that we need to call in order to kick off, as it were, our scrapers. So let's get the URL for the endpoint for the Amazon 2 scraper. To do this, let's navigate to the BrightData platform. Let's go to the My Scrapers tab. So let's click the 3 vertical aligned dots next to the Amazon 2 scraper, and let's select the Initiate by API menu option here. Then within this text area field, we can copy the endpoint for our Amazon 2 scraper like this. And let's paste the URL for our endpoint into our test scraper console app here, under the Amazon comment. So let's comment out these 2 lines that pertain to the TIOBE scraper because we only want to test the Amazon scraper in this part of the course. Let's include code to call our Amazon 2 endpoint like this here. So let's reference the appropriate request URI, which is the endpoint we have just copied from the BrightData platform for our Amazon 2 scraper. Let's call the post as JSON async method here. The first argument we pass to the post as JSON async method is our endpoint URI. The second argument is an anonymous object that will include our search parameter. The search parameter contains one of the programming languages contained within the TIOBE index. Remember, our system will eventually call our Amazon scraper 20 times in order to capture textbook data for each of the programming languages captured from the TIOBE index. Here, we just want to test capturing textbook data for one of the relevant programming languages. Great. So now we have the code set up to kick off the Amazon 2 scraper from our test scraper console app. So if you have stopped ngrok for some reason, like I have, you can create a new ngrok IP address in the same way we did before, using this command. Great. Let's go to the BrightData platform and register our WebHook URL appropriately using the delivery preference web page here for our Amazon 2 scraper. Then choose WebHook here as a preferred data notification method. Then within this URL field that dynamically presents itself on the page, let's insert the URL to our WebHook endpoint that we will run locally throughout the development and testing phase of our application. Right, let's save our delivery preference settings for the Amazon 2 scraper. Let's open the Web API project that contains our webhook code. Let's navigate back to the BrightData platform. Let's copy the collector ID for our Amazon 2 scraper to our clipboards. We can copy this value from the text area box on the Initiate by API tab here. Let's paste it into our webhook code here. Let's go to the BrightData platform and copy the collector_ID value pertaining to our TIOBE 2 scraper and let's paste it into our webhook code here. So because we are using the same webhook endpoint to handle the data notifications by multiple disparate scrapers from the BrightData platform, we need a way to distinguish each scraper from the other scrapers, i.e. from where the relevant data notification originated. So we can use an if statement for this purpose and evaluate the collector_ID. So with the dynamic object that we are using within our webhook to encapsulate the JSON data sent to our webhook from BrightData, we have a field named collector_ID. We can evaluate the value of this field within our if statement like this. So if the relevant collector_ID field is this value, we know that this data notification from BrightData pertains to the TIOBE 2 scraper. Else if the collector_ID field is equal to this value, this data notification pertains to the Amazon 2 scraper. So let's test to see if our Amazon 2 collector can successfully run and send an appropriate data notification to our webhook. Let's put in a breakpoint here within our code. So let's run our webhook code. Let's run the test scraper console app. Great. So if we go to the BrightData platform, we can see that the Amazon 2 collector is scraping. Great. So let's watch the output window for our webhook to see if we receive an appropriate notification from BrightData once the Amazon 2 collector has finished scraping. Oh, and the breakpoint has already been hit within our webhook code. So the scraping process has already completed and BrightData has sent our webhook a notification. Let's step through the code to see if the if statement is working correctly. And if we look at the output window, we can see that an expected data notification was sent to us from BrightData once the Amazon 2 scraper successfully completes. Great, so let's create the code within the webhook that will subsequently call BrightData at the appropriate endpoint to retrieve the results of the Amazon 2 scraper. Once we have the results, we can insert those results into an appropriate table within our SQL Server Database. So we haven't yet created the table to store our Amazon data in our SQL Server Database. So the next step is to create a model that serves as a template for the schema for the table where we wish to store the relevant Amazon data. Once we have created the model, we can then add the model to our DB context class and use EF Core data migration functionality to create the relevant Amazon table within our SQL Server Database. So within the entities folder, let's create our data model for Amazon. So let's create a class within the entities folder and let's name this class Amazon Book. Let's create a property within the Amazon Book class of type integer and let's name this property ID. This denotes the primary key for our Amazon Books SQL Server table that will be generated through code first migrations. Let's create a nullable string property and let's name this property input. Let's create an integer property named language ID. Let's create a nullable string property named title. Let's create a nullable string property named URL. Let's create a nullable string property named rating. Let's create a nullable string property named reviews. Let's create a nullable string property named price. Let's create a nullable string property named previous price. Let's create a nullable string property named image URL. And of course, each of these properties must have a public access modifier because this class will serve as the basis for our EF Core data migration for generating our Amazon Books SQL Server Database table. Great, so the next step is to open the scrape capture DB context file within the data folder here. Then we must add another property of type dbSet to our scrape capture DB context class. This property must be of the dbSet generic type, and here we must strongly type the dbSet type with the Amazon Book user-defined type that we have just created. Let's name this property Amazon Books. So this will be the name of the SQL Server table that we'll create through running an appropriate data migration. The Amazon Books SQL Server Database table will be used for the storage of data pertaining to the Amazon textbooks that will be scraped using our Amazon 2 collector. So to run our migration, let's first invoke the NuGet Package Manager console window like this. To create the appropriate migration C# class within our project, let's type in the add-migration command and give our migration a sensible name. So let's name this migration Amazon Books. Let's press the Enter key. Great, our migration code has been generated for us. So we have the up method to create our SQL Server table named Amazon Books. In the down method, we have code that will undo the effects of the code implemented in the up method. So to run our migration, let's type in update-database like this and press the Enter key. And that looks good. Let's open SQL Server Management Studio and see if the Amazon Books table has been created. And there it is. Excellent. Okay, so now we have two scrapers established on the BrightData platform that successfully collect desired data from the relevant web pages and then send appropriate data notifications to our webhook once the scraping process has completed. Our code then calls appropriate HTTP endpoints to retrieve the relevant datasets. With the processing dynamics involved in retrieving data first from the TIOBE index and then from the Amazon website, there is common functionality being executed. So this presents us with an opportunity to design our code in a way where certain functionality can be reused for both processes. So the reuse of certain code was not a concern when we only created code to scrape the TIOBE index. Now that we are about to extend the functionality of our application to include more than one data gathering task, where we are scraping data from two disparate entities on the internet, namely the TIOBE index and Amazon, we need to think about the design of our code in terms of design extensibility and code reuse. So the basis of how we are going to address these design concerns is by adding an abstract class and two classes that inherit from the abstract class. So two classes at the moment will inherit from the abstract class. One that represents the gathering of data from the TIOBE index, and the other one represents gathering the data from Amazon. So we'll first include an abstract class named DataHandler. This class will serve as the basis for creating a common design interface across the classes that inherit from the DataHandler abstract class, as well as the means for consolidating code that can be reused across the functionality performed by the classes that inherit from the DataHandler abstract class. So our class that we called TIOBE DataHandler will inherit from the DataHandler abstract class, and once we have updated this class accordingly, we'll move on to creating a class that will also inherit from the DataHandler abstract class, which will be named Amazon DataHandler. So essentially, the DataHandler abstract class creates a common interface for both the TIOBE DataHandler class and the Amazon DataHandler class. It also consolidates common implementation code or concrete code that can be used by both the TIOBE DataHandler class and the Amazon DataHandler class in one place, i.e. the DataHandler abstract class. Okay, so let's first create the DataHandler abstract class. To do this, let's right-click the DataHandlers folder and add a new class named DataHandler to the DataHandlers folder. Let's make this class an abstract class by appropriately including the abstract keyword within the class definition for the DataHandler class. Let's type CTOR and then press the tab key to create a constructor for the DataHandler class, like this. Let's include a parameter of the dynamic C# data type. Let's name this parameter JSON result. The next parameter is of our DB context type. So this parameter is of the scrape capture DB context type. Let's name this parameter scrape capture DB context. Let's create two read-only member variables that correspond to each of these parameters. So in order to generate the member variable counterparts pertaining to the constructor parameters, let's invoke the appropriate context menu from within Visual Studio by pressing Ctrl- while the mouse pointer is positioned over the relevant parameter. Then we simply select the appropriate menu option to create the appropriate member variable. Let's create a public property of type int and name it language ID. You'll see later the significance of this language ID property. Basically, each collection of Amazon books will pertain to a language retrieved from the TIOBE index. Later in the course, we'll create data capture code for capturing data about various YouTube channels that pertain to each programming language that has been captured from the TIOBE index. The scraping and capturing of data from YouTube will mean creating another class that inherits from the DataHandler abstract class. So we are effectively consolidating the storage of the language ID in one place across the classes that inherit from the DataHandler abstract class. So this property can be reused across the classes that inherit from the DataHandler abstract class. So basically, Amazon textbook data and YouTube channel data is always captured in the context of a particular programming language. So this is why the language ID property resides in the DataHandler abstract class and will be made available to the classes that inherit from the DataHandler abstract class. Let's create an abstract method named prepareData. This method contains one parameter of type JArray and does not return a value, so the void keyword is therefore appropriately included within the definition of the abstract method. So what is an abstract method? An abstract method is very similar to a method definition included within an interface. Any class that inherits from an abstract class that contains abstract methods must contain implementation for all of the abstract methods included in the relevant abstract class. So in this case, both the TIOBE DataHandler class and the Amazon DataHandler class will need to contain an implementation for the prepareData abstract method. So essentially, from a design perspective, we are ensuring that having a prepareData method that has the same method definition as the prepareData abstract method for the TIOBE DataHandler class and the Amazon DataHandler class is required. But the implementation in each of these classes for the prepareData method will be different. So from a human perspective, it can be simply explained like this. Preparing data for the TIOBE data capture functionality will be different from preparing data for the Amazon data capture functionality. However, each prepareData method will be called in the same way from the calling code. So each of these disparate data capture implementations must contain a method for preparing the data. Another common function that we need to include is denoted by an abstract method that we'll name getDataToProcess. The path to the relevant dataset stored within the JSON data collected by the TIOBE scraper may be different to the path to the relevant data stored within the JSON data pertaining to the Amazon scraper. So the need for converting the relevant data to a JSON array data type is common for both the TIOBE index data capture process and the Amazon data capture process. So having this abstract method ensures that the TIOBE DataHandler class and the Amazon DataHandler class have an implementation for this getDataToProcess method. Let's create an abstract method named addData. So both the TIOBE DataHandler class and the Amazon DataHandler class must implement a method for adding the relevant data to their respective SQL Server Database tables. So both the TIOBE DataHandler class and the Amazon DataHandler class will contain code within a method named addData for adding data through EF-Core to their respective SQL Server Database tables. Let's create an abstract method named removeData. Both the TIOBE DataHandler class and the Amazon DataHandler class will have a method responsible for initializing certain SQL Server Database tables before relevant data is added to the relevant SQL Server Database tables. So both the TIOBE DataHandler class and the Amazon DataHandler class will contain implementations for this remove data abstract method. The code for each of the implementations of the remove data abstract method will of course be different. One removes all the rows of data from the TIOBE ranked languages database table, and the other removes all of the data for the rows contained within the Amazon Books database table. Okay, so let's create a method called PrepData. This method is not an abstract method and will contain concrete implementation code. The implementation code within the PrepData method will be common to both the functionality pertaining to capturing data for the TIOBE index, as well as capturing data pertaining to the Amazon Books. So, we have already written code for the PrepData method, but it currently resides within the Fetch Data Background Service class. So let's open this file. Let's select this code here and let's copy it to our clipboards. Let's paste this code into our PrepData method within the DataHandler abstract class. So you can see a lot of red squiggly lines here. Let's adapt the code for our purposes within the DataHandler class. So let's modify the code appropriately. The JSON object returned object needs to be renamed to JSON result. Oops, and what went wrong there? Oh, it's because our member variable has a small j rather than a capitalized j. So let's remedy this by modifying the member variable to have a capitalized j here. Great. And because it's a member variable, let's precede each reference to the JSON result variable with this dot. Let's remove this line of code here. We don't want to instantiate the TIOBE DataHandler class here. We can replace this with the TIOBE DataHandler object reference with the this keyword. The this keyword refers to the current object. So the current object could be derived from the TIOBE DataHandler class, or for example, the soon to be created Amazon DataHandler class. Basically any class that inherits from the DataHandler abstract class. So the code within the PrepData method essentially first assesses whether the data returned from BrightData contains the data that we can insert into the relevant SQL Server Database table, i.e. either the TIOBE SQL Server table or the Amazon Book SQL Server Database table, or whether the data returned from BrightData contains a status property with a value of building or collecting, in which case the relevant dataset is not yet ready. So in this case, we are just writing the status to the console window. If, however, the data is ready, we are calling the getDataToProcess method, which will return the dataset as a JArray data type. We can call the current object, which could be of type TIOBE DataHandler or Amazon DataHandler. The current object is denoted by the this keyword. So this code doesn't need to know what the object type is. The code only needs to know that an implementation of the getDataToProcess method can be called on the current object, represented by the this keyword. The reason the code knows, as it were, that an implementation of the, for example, getDataToProcess method exists is because the abstract definition for this method exists within the abstract class, i.e. the DataHandler class, which is the base class for the TIOBE DataHandler class and will also be the base class for the soon-to-be-created Amazon DataHandler class. So our code here is not concerned with the code implementation of the getDataToProcess method, but only that the method named getDataToProcess is being called in the right way. And so we're passing the data returned from the getDataToProcess method to the prepare data method. The JArray data is the dataset that contains the data that we will insert into the relevant SQL Server Database table. Depending on what the type of the current object is, this will either be the TIOBE ranked languages database table or the Amazon Books database table. The prepare data method is called on the current object, which is represented by this keyword. The same principle that we have just covered regarding calling the get data to process method on the current object, denoted by this keyword, also applies when calling the prepare data method on the current object. The prepare data method involves preparing the relevant data to be inserted into the relevant SQL Server table, which, for example, could be the TIOBE ranked languages SQL Server Database table, or, for example, the Amazon Books SQL Server Database table. So our code here is not concerned with the concrete implementation detail of the prepare data method. Our code is only concerned with calling the method named prepare data. Our code here knows, as it were, that the prepare data method exists because an abstract method named prepare data has been appropriately defined within the DataHandler abstract class. And we can delete this code here because this code is concerned with removing data from our database, i.e. initializing the data in our database, as well as adding data to our database. In the prep data method here, we are only concerned with converting the raw data into a strongly typed list before adding the relevant data to our database. So if the code reaches this point within the if-else-if block, let's return true to the calling code. If the code reaches this point outside the if-else-if block, let's return false to the calling code. So let's create a method named saveData. The code implementation for the saveData method is common to, for example, the TIOBE DataHandler class and the Amazon DataHandler class. So consolidating this code within the DataHandler abstract class ensures that this code can be reused from objects derived from both of these types. The code simply calls EFCause save changes async method on our scrapeCaptureDB context object. This method must be called whenever data is added to the database using EFCause add async method. We'll create the implementation for adding data to the database in just a bit. Okay, so the next step is to create the Amazon DataHandler class. So let's create a class named Amazon DataHandler within the DataHandlers folder. Let's make this class inherit from the DataHandler abstract class. There is a red squiggly line under Amazon DataHandler. This is the compiler telling us, as it were, that we need to implement the abstract methods that we created within the DataHandler class. So an easy way within Visual Studio to create the relevant code stubs for these abstract methods is to place the cursor over Amazon DataHandler and press Ctrl-. This invokes the relevant context menu, and then let's select the option marked Implement Abstract Class. We still have a red squiggly line under Amazon DataHandler. This is because we need to pass specific arguments down to the abstract base class's constructor. So to do this, let's create a constructor for the Amazon DataHandler class. Let's include the appropriate parameters within this constructor. We can use the base keyword to pass the arguments passed into the Amazon DataHandler constructor down to the DataHandler abstract classes constructor. Of course, the Amazon DataHandler class inherits from the DataHandler abstract class. there is a red squiggly line under base. This is because for some reason C# isn't allowing the passing of an object of the dynamic type down to the base class. So we can get around this by explicitly converting this argument to the system.object type like this. Okay, and the compiler now seems to be happy with that, and the red squiggly line disappears. Let's create a member variable of type iList that is strongly typed with our Amazon book user-defined type. So before we continue creating the code for the Amazon Data Handler class, let's appropriately modify the TIOBE Data Handler class to inherit from the Data Handler abstract class. Firstly, a reference to the scrape data DB context class will be stored within the Data Handler abstract class. If we go to the Data Handler abstract class code, you can see that we have a private field used for storing the scrape capture DB context object. Let's change the access modifier here from private to protected. This protected variable will be accessible from within the classes that inherit from the Data Handler class. We next need to modify the constructor for the TIOBE Data Handler class so that the scrape capture DB context object passed into the constructor is passed down to the base class. So let's modify the constructor so that it passes down the relevant arguments to the Data Handler base abstract class in the same way that the constructor within the Amazon Data Handler class does. So let's copy the relevant code from the Amazon Data Handler class and appropriately paste it into our TIOBE Data Handler class. We can see here that we don't need this read-only variable that is used to reference an instance of the scrape capture DB context object. So let's remove this definition, and let's also remove this code here from within the constructor. We now can access a reference to an instance of the scrape data DB context object from within objects derived from classes that inherit from the Data Handler abstract class. So we have a red squiggly line under TIOBE Data Handler. This is the compiler telling us that we haven't implemented all the abstract methods defined within the Data Handler abstract class. So even though we do seemingly have methods in this class set up for the relevant abstract method definitions defined within the Data Handler abstract class, we are not overriding the abstract class method definitions. So to correct this, we need to appropriately include the override keyword within the relevant method definitions like this. Great, the compiler is happy and the red squiggly lines disappear. Okay, so let's go back to the Amazon Data Handler class, and let's create the implementation code for the abstract methods. The implementation for the getDataToProcess method is pretty straightforward. It simply involves an explicit data conversion from the dynamic data type passed as an argument to the method into a J array before the J array is returned to the calling code. Okay, so before we implement the code for the prepareData method, let's create a private method called setLanguageID. Within this code, let's extract the relevant programming language from the JArray data, like this. Then let's use the language name to query the TIOBE ranked languages SQL Server Database table for its associated unique ID. So we want the primary key related to the relevant programming language. We can do this using EF_core and link. So we have a public property, language ID, within the DataHandler abstract class. It doesn't need to be public, it just needs to be accessible from the classes that inherit from the DataHandler abstract class. So let's write a link query to return the ID value of the relevant language stored within the TIOBE ranked languages SQL Server Database table. We can retrieve this ID value by querying the TIOBE ranked languages table using the relevant programming language name that is extracted from the data retrieved through a BrightData scraping operation. Note how we are setting the language ID property of the DataHandler abstract class from within a method that resides within the Amazon DataHandler class. We can do this because the Amazon DataHandler class is derived from the DataHandler abstract class, and the language ID property is defined with an appropriate access modifier. So we have defined it with the protected access modifier. We have a red squiggly line here because we need to bring in the learn IT resources BD API.entities namespace. Okay, so we can now call our private setLanguageID method like this. This will in effect mean that we can now access the language ID property value from anywhere within our Amazon DataHandler class. This value is useful because each object derived from the Amazon DataHandler class will be related to a specific programming language. Then let's use link to project the dataset returned from BrightData into a list that is strongly typed with our Amazon book type. So we are using the select extension method to project the data fields extracted from the raw data retrieved from BrightData into a strongly typed list that is strongly typed with the Amazon book data type. So we are preparing our data to be inserted into the Amazon Books SQL Server Database table. Remember, our Amazon Books SQL Server Database table is based on the Amazon Book user-defined type. So EF_core will understand, as it were, a list that is strongly typed with the Amazon Book type. This will make it easy to insert the relevant list into our database using EF_core. Remember, the Amazon Books SQL Server Database table was created through code-first EF_core migrations and was based on the Amazon Book user-defined type, or model. Let's assign the projected data to our member variable named Amazon Books. Now we can create code within the addData method to add the relevant data to our database using EF_core. Let's add some output status within the addData method. This data could prove useful during the testing phase. So let's first create an if statement to make sure that the Amazon Books list contains data to add to the database. If the Amazon Books list contains data, let's add it to the database by calling the addRangeAsync method on the scrape DataDB context object instance like this, and pass in the Amazon Books list as an argument to the addRangeAsync method. Then to save the data, we can call the saveData method that we created within the DataHandler abstract class like this. If the code reaches this point, let's return true because it means that the relevant data has been successfully added to the relevant SQL Server Database table. If the code gets past the if statement block, it means that no data has been added to the SQL Server Database table. So let's return false here. So you can see here within the DataHandler abstract class that we have the saveData method. Okay, so let's implement the code within the Amazon DataHandler class for the removeData method. Let's copy the implementation for the removeData method that resides within the TIOBE DataHandler class to the removeData method that resides within the Amazon DataHandler class. We are using the await keyword here in an attempt to call EFCOR's execute SQL raw async method asynchronously, but we haven't yet included the async keyword within the method definition of the remove data method. So let's get rid of the red squiggly lines by appropriately including the async keyword within the remove data method definition. Then let's modify the code so that the relevant SQL code deletes the database rows from the Amazon Books SQL Server Database table that pertains to the relevant language ID. So for example, if the relevant programming language is C#, all the textbook data pertaining to C# will be deleted from the Amazon Books SQL Server Database table. So this remove data method will be called to initialize the relevant database table before the add data method is called to add the freshly scraped data, as it were, to the Amazon Books SQL Server Database table. I noticed earlier that within the TIOBE data handler class's add data method that we are directly calling the save changes async method on the scrape capture DB context object instance. We can do this, but it is better to reuse the code that we have created for this purpose within the data handler abstract class. So let's replace this line of code with a call to the save data method. So this is a much cleaner way of coding this functionality where the save data method can be reused for this purpose from all classes that inherit from the data handler class. And within the remove data method within the TIOBE data handler class, we want to remove the data from all of the tables relevant to scraped data within our SQL Server database. So here we want to initialize the entire system. We do it here because the first stage of our system is scraping and capturing data pertaining to the TIOBE index. So let's also create functionality here to truncate the Amazon Books table here. So before we scrape the TIOBE index data and insert it into the TIOBE ranked languages SQL Server Database table, we want to ensure that not only the TIOBE ranked languages SQL Server Database table is empty, but associated tables are also empty, like for example the Amazon Books table. We should in fact execute functionality to empty the tables associated with the TIOBE ranked languages table, like the Amazon Books table, before we empty the TIOBE ranked languages table. That's great. So we have now created the code to implement all the abstract methods that we created within the data handler class, both within the TIOBE data handler class and the Amazon data handler class. We have in effect created a clean design and implementation for code that captures scraped data from the TIOBE index and scraped data from the Amazon website and inserts the data appropriately into our SQL Server Database tables. But we still need to create the appropriate calling code from within our handle BD data webhook controller class and our fetch data background service class. So firstly, let's create an enum type that will be used to distinguish between the different data handling task types within our application. At the moment, we have created two types of data handling tasks, if you like. One for handling the TIOBE index data and the other for handling the Amazon Books data. So let's create our enum. Let's firstly create a folder named enums. Within this folder, let's create a class, and let's create the class with the default name given to it. Let's remove this class definition, and let's create a definition for our enum. Let's create a public enum named scraper type. Within the scraper type enum, let's add three list items. The first one is named TIOBE, the second one is named Amazon, and the third one is named YouTube. So each of these items pertains to a scraper that we have created or will create on the BrightData platform. We have so far created two scrapers, one to scrape the TIOBE index and one to scrape specific search results on the Amazon website. We'll create the YouTube scraper later in this course. So let's write the calling code for the TIOBE data handling process and the Amazon data handling process. We'll create the data handling process for YouTube a little bit later in this course. So next, let's go to the Fetch Data Background Service class. Within the initialize background service method, let's include a parameter of type scraper type, which is the type of the enum that we have just created. Let's create a member variable of the same name. And assign this member variable the value that will be passed into the scraper type parameter that we have just included within the initialize background service method here. Let's go to the code within the post method contained within the handle BD data WebHook controller class and modify our code that calls the initialize background service method to include an appropriate argument value for the scraper type parameter. So if the data notification passed from BrightData into our webhook pertains to the completion of a TIOBE scraper job, then let's pass in scrapertype.tiobe here. Let's bring in the learn IT resources BD API.enums namespace. If the data notification passed from BrightData into our webhook pertains to the completion of an Amazon scraper job, then we pass in scraper.amazon here. And we are not yet calling the initialize background service method for when a notification is sent after an Amazon scraper job completes. So let's create the code here to do so. Then we pass in scrapertype.amazon here. Okay, so let's go to the Fetch Data Background Service class. Within the Process Dataset Async method, let's modify our calling code appropriately. We can clean up the existing code substantially because we have now created a clean design for our data handling code. So let's first remove this unnecessary code here. Let's create an if-else-if block to check the relevant scraper type. This will inform our code here, as it were, on how it should instantiate the relevant data handler class. So let's declare a local variable of type data handler here and initialize it to null. Then let's create code for instantiating the TIOBE data handler class. We need to make sure that we have a reference to an instance of the scrape capture DB context object. So rather than use dependency injection to get a reference to an instance of the scrape capture DB context object, we can use the async service scope object to retrieve the scrape capture DB context object from the services collection. The reason we are not using dependency injection for this purpose is because the code that utilizes the scrape capture DB context object, in this case, is running inside a background service. Then we can pass that object instance into the constructor of the TIOBE data handler class here. Else, if the scraper type is scrapertype.amazon, let's create code to instantiate a data handler object of type Amazon data handler. Oops, I made a bit of a typo when I called this class Amazon DataHandler. So Let's rename Amazon DataHandler to Amazon DataHandler here. And let's make sure that all references to Amazon DataHandler are renamed to Amazon DataHandler. You, of course, may not need to correct this mistake if you named it correctly to begin with. This code will work as long as our references to the class name are consistent, but it is always good to name code elements appropriately. And we have now removed the T from Amazon DataHandler from the code that instantiates an object from the Amazon DataHandler class. So if the DataHandler object instance is not null, let's call the prepData method. Then let's call the addData method. Then let's set the isEnabled Boolean value to false if the addData method returns true. This, in effect, will stop the background service from running our code every 5 seconds, which is what we want because at this point, we would have successfully captured the relevant data into our SQL Server Database table. Okay, so we only want the addData method called if the prepData method was carried out successfully. And we want to initialize the relevant SQL Server Database tables appropriately before adding data to the database. So let's call the removeData method before we call the addData method. And our calling code is now super clean and easy to read. It will also be super easy to maintain moving forward. And the code looks good. Okay, a minor modification can be included here. Just to be consistent, let's include the this keyword here. Okay, this is exciting. Let's test our code. Let's make sure that our test scraper console application is open. Let's make sure that ngrok is running so that BrightData can call our webhook that will be listening on our local machines. If you have shut down ngrok for some reason, you'll need to run the ngrok command to generate a new local IP address. You'll also need to update the relevant delivery preference field on the BrightData platform for each of your scrapers so that BrightData can call your webhook on your local machine. Let's go to the delivery preferences page of our Amazon 2 scraper and make sure that the new ngrok IP address is appropriately updated with the URL field where our webhook URL is registered. Great, let's press the update button. We are only going to test the Amazon 2 scraping and data capturing functionality for now, but let's also make sure that our delivery preference web page is updated appropriately for the TIOBE 2 collector. So let's update the URL field with the newly created ngrok URL for the webhooks URL field within the delivery preferences web page for the TIOBE 2 collector. Just a reminder, you will of course not need to make these delivery preference URL updates if you have not shut down ngrok from the last time you ran the ngrok command. Let's click the update button here. Let's go to the Runs tab for the Amazon 2 collector. Great. Let's go to the test scraper console application and update the input variable so that we are scraping Amazon for textbooks pertaining to programming in Python. Let's run our Web API project so that our webhook is listening for data notifications sent from BrightData. then let's run our test scraper console application to kick off, as it were, our Amazon 2 collector on the BrightData platform. Okay, let's go to the BrightData webpage where we can see our run in action here. So our Amazon 2 collector is certainly scraping. Okay, wow, that's finished scraping, and that was pretty fast. And if we look at our output window for our Web API application, we can see that our WebHook has been successfully contacted by BrightData, and that it looks like the scraped data has been successfully inserted into the Amazon Books SQL Server Database table. Let's verify this by looking at the Amazon Books table within SQL Server Management Studio. And look at that, our code has successfully captured the scraped data from Amazon within our Amazon Books database table. And like magic, we have our desired data for 16 textbooks pertaining to the Python programming language captured within our Amazon Books SQL Server Database table. Excellent. So for good measure, let's also scrape the Amazon website for textbook data pertaining to the C# programming language. So let's assign C# to the input variable within our test scraper console application. Let's make sure our webhook is listening on our local machines. So let's run our Web API project. Let's run our test scraper console app to kick off, as it were, our Amazon 2 scraper, which will now scrape data pertaining to textbooks written about the C# programming language. Let's go to the BrightData platform. Excellent! And we can see that our Amazon 2 scraper is running. And if we now go to the output window for our webhook, we can see that it looks like our scraper and data capture functionality has run successfully. Let's confirm this by looking at the Amazon Books SQL Server Database table through SQL Server Management Studio. Excellent! So we have now scraped textbook data from the Amazon website pertaining to Python and C#. Okay, so let's open our Blazor web app project and create the code to display the data pertaining to textbooks scraped from Amazon in an aesthetically pleasing way to the user. So firstly, let's create a model class that serves as a template for our Amazon Book data. So let's create a class within the entities folder named Amazon Book. We have already created this model class within our Web API project. So let's go to our Web API project and copy the properties from the Amazon Book class within our Web API project into the Amazon Book class within our Blazor project. So far, we have the TIOBE ranked language class and the Amazon Book class, which map directly through EF Core to relevant tables within our SQL Server database. I want to create a data structure that houses the list of data pertaining to the TIOBE ranked programming languages captured from the TIOBE index, as well as the list of Amazon textbook data related to the relevant TIOBE ranked programming language. This data structure will enable our code to store all the TIOBE ranked language data joined to related Amazon textbook data in one data structure, and this data can be retrieved through one link query using a join between the TIOBE ranked languages SQL Server Database table and the Amazon Books SQL Server Database table. So let's create a folder named Models. Within the Models folder, let's create a class named Amazon Books by language. So the properties pertaining to the TIOBE data can be copied from our TIOBE ranked language class here. So let's copy these properties and paste them into our Amazon Books by language class. Then let's create a new property of type list that is strongly typed with the Amazon Book type. Let's name this property Amazon Books. Okay, so before we create the code to query our database from the TIOBE data and associated Amazon textbook data, we need to add a dbSet property for the Amazon Book type to our scrape capture DB context class. So let's create a property within the scrape capture DB context class named Amazon Books. This property maps directly to the Amazon Books SQL Server Database table that we have already created through EF Core migration code that we ran from within our Web API project. So let's create a new service that will house the code created for querying our SQL Server database for both the TIOBE ranked languages and associated Amazon textbook data. So note that the TIOBE ranked languages SQL Server table has a one-to-many relationship to the Amazon Books database table, which means one programming language, for example Python, can have one or many Amazon textbooks associated with it, but a particular Amazon textbook can only be associated with one particular programming language stored within the TIOBE ranked languages table. Okay, so let's create a new service class. Before we create a new service class, let's create the interface that will be implemented by our new service class. So let's create an interface named iAmazonService. Let's create a method definition for the iAmazonService interface named getAmazonBooks grouped by language. This method returns a list that is strongly typed with the Amazon Books by language type. The return value is wrapped, as it were, by the task type because this method will be called asynchronously using async_await. Okay, so let's create our service class. Let's name this service class Amazon Service. Let's make the Amazon Service class implement the iAmazonService interface. So we must implement code for the getAmazonBooks grouped by language method. So let's write a link query that returns the data structure that includes a list of programming language data and associated list of Amazon textbook data. Note that the async keyword has automatically been appropriately added to the method definition. Of course, the async keyword must be included in the method definition like this when we are using async_await task functionality within the relevant method so that certain code is executed asynchronously. So, one or multiple textbooks can be associated with one particular programming language, but only one textbook can be related to a particular programming language. Before we write our link query, let's create a constructor that accepts an object instance of type scrape capture DB context as an argument. This DB context object instance will be injected into our service class automatically through dependency injection. Okay, so the first line of our link query retrieves all the data rows within the TIOBE ranked languages database table. The second line joins the TIOBE ranked languages table to the Amazon Books table. The third line instructs EF Core to join the two tables where the TIOBE ranked languages.id column value equals the Amazon Books table's language ID field value. So in effect, the primary key value in the TIOBE ranked languages table is joined to the foreign key value within the Amazon Books SQL Server Database table. And the third line includes the code into grouping, which instructs EF Core to associate a list of related Amazon book data to its related programming language. And lastly, on the fourth line, we want this data ordered in ascending order from the top-ranked programming language, ranked number 1, to the bottom-ranked programming language, ranked number 20. So in our link query, we are ordering the data by the rank order field, which will be a unique value between 1 and 20. Then we use the select new link code to create a new object of type Amazon Books by language to house data for each item within the list that will be returned from this method. And note how we are able to group the related Amazon book data into a list here. So the data returned by the into grouping code here is converted into a list here using the toList method. Before we create the Razor page that will be responsible for outputting the data returned from our link query to the screen in an aesthetically pleasing way, we must first register our Amazon service type for dependency injection. So to do this, let's open the program.cs file. Let's duplicate the code we created earlier for registering the TIOBE service type for dependency injection. Then let's change this code so that the Amazon service will be registered for dependency injection. Okay, the next step is to create a Razor component where we'll create the markup code and logic in order to display the data returned from our services get Amazon Books grouped by language method in an aesthetically pleasing way to the user on a web page. So within the pages folder, let's create a Razor component named Amazon.Razor. Let's set the @renderMode directive to interactive service. So this means this Razor component will be a Blazor server component. So this means a signal R connection will be established between client and server. So this means state will be stored between client and server on the server. The C# code will run on the server as opposed to on the browser on the WebAssembly technology. Note that the Razor server component will be rendered on the server. Let's include a using directive to bring in the scraper datadisplay.models namespace. Let's include another using directive, this time to bring in the scraper datadisplay.services namespace. Let's use the @page directive to appropriately establish the root for this Razor component. Let's use the @inject directive to use dependency injection to inject an instance of the Amazon service type into our Razor component at runtime. Within the @code section of our Razor component, let's create a private variable of type list that is strongly typed with the Amazon Books by language type. Let's include a constant that is assigned the base URL of the TIOBE index website. This will be used to reference images that represent the programming languages stored within the TIOBE ranked languages table. So let's add an event handler for the onInitialized async lifecycle hook. So to do this, we can type override and then press the spacebar key. We can now select the onInitialized async method from the drop-down list here. And an appropriate method definition is automatically generated for the onInitialized async event handler method. One thing we need to remember to do is to appropriately include the async keyword within the onInitialized async event handler method. Then let's create the code to assign the value returned from a call to our Amazon service classes get Amazon Books grouped by language method to our Amazon Books by languages variable. By including this code within the onInitialized async lifecycle hook, we are ensuring that this code is run when our Razor component is loaded. So above the @code section, let's create our markup code. So let's create an if statement that assesses whether the Amazon Books by languages variable is null. If it is null, let's output a basic loading indicator to the screen. If, however, the Amazon Books by Languages variable contains data, let's output the data in HTML format to our web page. Let's create a div element and appropriately include basic Bootstrap classes within the div element. Let's add a heading for our Razor component. Let's add inline CSS style code to this h1 element to align our header text centrally. Let's create a parent div tag in which we'll include the output of our programming language data as well as the associated Amazon textbook data. Within this div tag, let's create a for each loop to iterate through the list stored within the Amazon Books by Language variable. Let's write Razor code to output the details of each language to the screen. Notice that we are using Bootstrap 5 classes to style the relevant HTML elements. So for each programming language, we are outputting the programming language TIOBE ranked order number, which will be incremented from 1 to 20, an image pertaining to each programming language, as well as the programming language's name. Okay, let's open the nav menu.razor file and include a link within the side menu bar so that we can access our newly created Razor component from within the side menu bar. So let's duplicate this side menu bar item. Then appropriately change the new menu item to point to our new Razor component. Let's run the code. Great, so let's click on the TIOBE index menu option. Great, it outputs the relevant ranked programming languages to the screen. Let's click the Amazon Books menu option here. Great, and we are now also outputting the ranked programming languages to the screen from within our new Razor component. So the next step is to write the code for outputting the data in an aesthetically pleasing way for a list of Amazon textbooks that will be displayed in a multi-item carousel displayed positioned under each of the relevant programming languages. So there will be multiple carousels displayed on this web page. These carousels represent textbooks for each TIOBE index ranked programming language. So within the multi-item carousel, we want data for 4 textbooks to be displayed at a time for each programming language to the user. So the user can press the navigation chevrons positioned at the left and right ends of the carousel to navigate through the textbook data, 4 items at a time. Okay, so let's create the code for our multi-item carousel component within a child Razor component. We'll appropriately call the child component from within the Amazon.Razor parent component to position the carousel component just below each of the relevant TIOBE ranked languages. So within the Pages folder, let's create a Razor component named AmazonBooks.Razor. Let's use the @renderMode directive and set it to interactive server. So this means the code for this component will run on the server. So this component works the same way as any component created within a Blazor server project. Let's add an @using directive that brings in the scraper data display.entities namespace. Within the @code section, let's create an integer property named langID. let's create a property of the list type that is strongly typed as Amazon Book. Let's name this property Books. So both of these properties denote parameters that can be used by a parent component to pass relevant argument values down to this child razor component. One way of knowing if a razor component is a child component is that a child component will not have an @page directive at the top of the code, which denotes the root for the relevant razor component. Only parent razor components contain routing information. I'm not going to go into detail regarding how to create the multi-item carousel code. I will, however, broadly discuss what I'm doing while creating the code. Remember, you are able to see the final code on GitHub at this URL. Firstly, let's create an if statement that checks to see if the books argument passed down from the parent is not null. And if the books argument is not null, the if statement checks if the books list contains any list items. If the if statement returns true, the carousel containing the relevant textbook data is outputted to the screen. So let's create the code for the carousel. Let's create a div element and let's set its ID attribute to a concatenated string value. The string contains the literal text, carousel captions, and the language ID pertaining to the TIOBE ranked programming language. By adding the unique language ID to the ID of the div element that represents a carousel, we are able to include multiple carousels on our web page, and each carousel can be uniquely identified in our code. Each carousel can be uniquely identified in code by a unique value provided by the language ID value. This unique language ID is passed down to the lang ID parameter that we have included in this child razor component. So we want each ranked language to have a carousel, which will contain multiple textbooks scraped from Amazon. So let's include the Bootstrap 5 classes, carousel, and slide within this element. So we want this div element to be our carousel, and we want the items in our carousel to slide. Then let's include the Bootstrap 5 data attribute named data-bs-ride within the div element and set it to carousel. Let's create a new div element within the parent div element that we have just created. Let's include a Bootstrap class within this div element named carousel-inner. So let's create a for loop that iterates through each list item that denotes a textbook that is stored within the list passed down from the parent razor component to this child component into the books list parameter. Then let's use the skip take link methods to take 4 items at a time from the books list. If the books variable is not null and has more than 0 items, then let's add the books to the carousel, as it were. So each Bootstrap carousel item in our multi-item carousel will contain 4 textbooks, as it were. 4 textbooks are displayed to the user at a time within the relevant carousel. The user can then scroll through the carousel items using the navigation buttons on the sides of the carousel to view the other items in the carousel. So let's create an if statement that checks the x value. If the x value is 0, this means that the loop is currently on the first item, so let's set a variable to active at this point in the loop. This will allow us to set the first item in the carousel to be displayed by default within the carousel to the user. So below the if statement, let's create the markup code for a carousel item. So within this div element representing a carousel item, let's include the carousel item Bootstrap 5 classes. Within this class attribute assignment, we are including the CSS class active variable. So if the x variable is 0, denoting the first iteration in the relevant loop, the CSS class active variable will be set to active. Active is a Bootstrap 5 class that will set the first item, which contains data for 4 textbooks, to the default carousel item, meaning the first 4 textbooks will be displayed to the user in the relevant carousel by default. If the x variable's value is greater than 0, denoting iterations of the loop greater than the first iteration of the loop, the CSS class active variable is set to an empty string, meaning that the active class is not included in the relevant carousel item div tag. So this means the first 4 textbooks, as it were, will be displayed to the user in the relevant carousel by default. Let's set the height of the div element to 200 pixels using CSS inline styling here. Let's include a div tag within the div tag representing a carousel item that contains the container-fluid Bootstrap 5 class. Within the, as it were, container-fluid div element, let's include a div element that includes the row Bootstrap 5 class. Within the, as it were, row div element, let's create a for each loop for traversing the books list. So we are going to encapsulate the markup for each book within its own child Razor component. So we'll get back to this part of code in just a bit. So let's include an else block here where the break statement is called if this else condition is met. So this means the code will break out of the loop once data for all of the books pertaining to the relevant programming language have been included within the relevant carousel. But let's first include the markup code to create the navigation chevron buttons that the user can use to scroll through the items stored in the carousel. Let's include the button element to denote one of our carousel navigation buttons. So this button denotes the previous button. So when a user clicks the button represented by this code, the previous 4 textbooks, as it were, will be displayed to the user within the relevant carousel. Let's also include the data-bs-target Bootstrap 5 data attribute and set it to the ID of the relevant carousel. So this value is referencing the ID of the carousel that houses the navigation buttons contained within the relevant carousel. In CSS code, HTML element IDs are always preceded by the hash symbol, like we are doing here. So the ID is made up of a concatenation of the literal text, carousel captions, and the unique programming language ID passed down to the lang ID parameter within this child Razor component. So this is how the navigation buttons are appropriately linked with the relevant carousel on the UI. Then set the Bootstrap 5 data attribute named data-bs-slide to prev. This means that this button will be used to scroll the carousel to display the previous 4 textbooks, as it were, within the relevant carousel. This span element within the button element includes the less than chevron icon. This is signified by including the Bootstrap 5 carousel-control-prev-icon class within the span element. So let's duplicate this button and modify the relevant Bootstrap code so that the button denotes the next button for the relevant carousel. So to do this, please follow the modifications that I'm making here to this button element and associated child span elements. Let's create the child Razor component that will denote a single textbook displayed within the carousel. So let's set its @renderMode directive to interactive server. This means that the C# code will run on the server and the component will be rendered on the server. Let's create a public property within the @code section that is of type Amazon Book. Let's name the property Book. Let's decorate this property with the parameter attribute, which means a parent Razor component will be able to pass down an object of type Amazon Book to this parameter. Let's write the code to output the relevant markup that will represent a textbook to the UI. So if the book argument is not null, output the markup that represents the book. So I won't explain all the markup code, but I'll just cover the essentials. So the parent div tag contains a child div element that contains an image element that references the Amazon book image URL that we have scraped from Amazon. The image element is wrapped in an A tag that points to an Amazon website URL for a web page that contains information about the relevant Amazon product, the relevant textbook. We are including a button here pertaining to each textbook that, when clicked by the user, will present the user with a modal dialog where all the data that we have scraped pertaining to the relevant textbook will be displayed on the relevant modal dialog. We'll write the code for the modal dialog a little bit later. So the data-bs-target attribute is set to the ID of the relevant modal dialog, which is a concatenation of the literal text, static backdrop, and unique identifier of the relevant textbook. So each textbook will have its own modal dialog. The data-bs-target attribute is how we are able to link a modal dialog with the relevant textbook displayed within a carousel. We'll write the code for the modal dialog in just a bit. The modal dialog will display Amazon data that we have scraped and captured pertaining to the relevant textbook. So let's go back to the Amazon Books Razor component and include a reference to the Amazon Book link child Razor component. Let's pass in the book variable, which is an Amazon Book object that encapsulates all of the data scraped from Amazon for the particular book that the relevant object represents. Okay, and we of course also need to appropriately reference the Amazon Books Razor component from within its parent Amazon Razor component. The Amazon Books Razor component of course encapsulates the code for the Carousel component. Note that we are passing in the unique ID pertaining to the programming language to which, as it were, the carousel that contains the Amazon books pertains. And we are passing in the list of Amazon books that pertains to the relevant programming language to the second parameter, which is named books. Let's run the code. Okay, so 4 items are displayed for Python and C#. I have scraped data for Python and C# by running the Test Scraper console app for each of these programming languages. Please, if you are set up to do so, scrape data for a few programming languages so that you have a decent amount of textbook data displayed in your carousels below each relevant programming language. So the layout is not great. The textbook images are too large for the carousel. So let's see what we can do to fix this. So let's change the width and height property for this inline CSS styling code from 100% to an appropriate PX value. So these are just estimated values. Just a reminder, you are able to view the final code on GitHub. These are of course UI-related settings with which you may wish to experiment. Of course, styling your UI can be subjective, but here we are making sure that our UI is at least functional. So we want to make sure that the entire textbook image is visible and the button that when clicked loads the relevant modal dialog is also visible within the relevant carousel. Okay, so all we need to do is open the amazonbooks.razor file and change the CSS height property from 200 pixels to 290 pixels. So we are making the carousel item container big enough to contain the entire image that represents the textbooks, as well as the buttons displayed below the relevant textbook images. Let's run the code. And that looks much better. Great. So, the other issue we have is that currently the items within the carousel are not sliding. So the user cannot scroll through the items in the carousel. The user should be able to use the Prev and Next navigation buttons presented respectively on the left end and right end of the carousel so that the user can scroll through the items in the carousel backwards using the Prev button and forwards using the Next button. The reasons for this is that if we look at the app.razor file, we have a reference included to reference the appropriate Bootstrap 5 CSS file, which resides on our local machine. This reference is included by default when we create a Blazor web app project. However, the jQuery code that needs to be included for some Bootstrap 5 components like our carousel component is not included by default. So to include a reference to the relevant jQuery code, we can use a CDN link within a script tag. So let's search Google for JavaScript Bootstrap 5. Okay, let's navigate to this link that has shown up as the first item in our results. And this is the code for the script element that contains the relevant CDN link that we need to include within our app.razor file. The code within the JS file that the relevant script tag references will provide the functionality that we need to make our carousel appropriately slide, meaning a user will be able to scroll through the relevant textbooks within the carousels using the carousel's navigation buttons. Okay, so let's copy the relevant script tag to our clipboards here. Let's open our app.razor file and appropriately paste the code copied to our clipboards here within the app.razor file. Okay, let's save the changes that we just made to the app.razor file and run our code. And now we are able to use the carousel's Next and Prev buttons to navigate through the textbook items contained within our carousel. And all of the carousels on the UI are working as expected. Excellent. But the carousel's Next and Previous navigation buttons are not very well defined at the moment, so let's use CSS styling code appropriately to make the Next and Previous buttons stand out on the UI. So we can see here in the Amazon Books.razor file that the Next and Previous buttons contain Bootstrap classes. The Previous button contains a CSS class named carousel-control-prev. The Next button contains a class named carousel.control.next. So we can use these Bootstrap classes to customize the way the Next and Previous buttons appear on the UI. So let's open the app.css file and let's include these two classes like this. Let's set the background color for the two buttons to gray. And let's set the width of these two buttons to 30 pixels. Sometimes when you change code for a CSS file that has been cached on the user's browser, the changes don't instantaneously propagate from server to client. So one way to force the relevant CSS code to take effect on the client immediately is to add a version number to where the CSS file is referenced in code through the relevant link tag. So by adding a version number parameter to the relevant path of the CSS file like this, we are forcing the existing CSS file cached on the client to be superseded by the latest version of the CSS file that has now been updated on the server. So let's run the code. And great, that looks much better. It is now easy to see the navigation buttons on the carousels. And look at that, they are functioning brilliantly. And if we click the images that represent the relevant textbooks on the UI, we are navigated to the appropriate product on the Amazon website. Excellent. It just wouldn't be practical from a UI design point of view to include all of the fields. We are currently just including the image of the book within the carousel. We have also included a button just below the image of the book. Currently, nothing happens when we click this button. So we want to display a modal dialog when the user clicks the button pertaining to the relevant book. The modal dialog will display all of the details that we have scraped from the Amazon website in relation to the relevant book. Okay, so we want to encapsulate this modal dialog functionality within its own child Razor component. Note, to create the modal dialog effect, we are going to use Bootstrap 5 classes. So let's create a Razor file within the Pages folder, and let's name our new Razor file AmazonBookDetails.razor. Let's start by including a using directive to bring in the scraper data display.modals namespace. Within the add code section of the Razor file, let's include code to define a public property of type Amazon Book. And you can see that we have made this variable nullable by including the question mark symbol at the end of the Amazon Book type definition. So there's a red squiggly line under Amazon Book, and this is because we are currently bringing in the scraper data display.modals namespace here, and we should be bringing in the scraper data display.entities namespace. So let's update our code to fix this. Let's name our property book. I'm going to fast forward the creation of the modal dialog code because this is just standard code for creating a modal dialog using Bootstrap 5 classes. You can either copy the code for this from the Bootstrap 5 website at this URL, or you are of course welcome to simply copy the code from the relevant GitHub repository webpage, which can be found at this URL. One thing I do feel that I should explain, however, is the ID here that we are giving to the div tag that denotes the modal dialog. So we need to bear in mind that each textbook represented on the UI will have an associated modal dialog. When the UI is first loaded, all of these modal dialogs will be hidden. When the user clicks a button below a particular image representing a textbook, the relevant modal dialog pertaining to the relevant textbook will be presented to the user. So my point is, this ID must include a unique identifier, and we are using the ID field that each Amazon book has associated with it, stored in our SQL Server Database, to uniquely identify the modal dialog that should be presented to the user when the user clicks the relevant button on the UI. So the relevant ID field has been assigned a literal text value of static backdrop plus the unique Amazon book ID that we are storing in our SQL Server Database table. We are of course storing details about the Amazon textbooks that we scraped from the Amazon website within our own database. So all we are doing here is associating relevant Modal Dialog related Bootstrap 5 classes to relevant div tags in order to create the Modal Dialog effect. This code is just standard code that has been copied from the Bootstrap website at this URL, and you are of course able to reference the final code of this application on GitHub. So here we are including the image of the textbook on the Modal Dialog. And we are including the relevant details of the textbook below the image. These details have of course been scraped from Amazon. So, title, the number of reviews, the previous price of the textbook, and the current price of the textbook. We have an A tag here that points to the URL of the textbook product to which these details are related. This URL field has been scraped from the Amazon website and captured within our Amazon Books SQL Server Database table. The target equals underscore blank code here simply means that the web page displayed as a result of the user clicking this link will appear in a new tab on the user's browser. And one thing that I have not yet done is I have not yet made this book property a parameter, so that the relevant book object can be passed down to the Amazon Book Details child component from a parent Razor component. So to make this property a parameter, we simply decorate the property with the parameter attribute like this. Once we are happy with the code for our Modal Dialog, we must include a reference to the Amazon Book Details child Razor component, which denotes the Modal Dialog, within the parent Razor component, which is the Amazon Books Razor component. Note that the Amazon Books Razor component is also a child Razor component that is referenced by the Amazon parent Razor component. So we must pass down the book object within the loop here to the Amazon Book Details child Razor component through the book parameter we created within the Amazon Book Details child Razor component. Let's run the code and test our Modal Dialog functionality. Great! And let's add in the functionality to close the Modal Dialog, so that the user can close the Modal Dialog. So to do this, we must include this data-bs-dismiss equals modal code within the relevant button element like this. Data-bs-dismiss is a Bootstrap 5 data attribute. Let's test this code. Great. Let's test our Amazon link. Great. But the close button doesn't look great like this. So to fix this, let's include a Bootstrap 5 class reference within the div tag that wraps the close button. And the Bootstrap class that we need to apply for this purpose is named modal-footer. So within this code, we are essentially letting Bootstrap 5 appropriately place the close button within the footer of the relevant modal dialog. Let's run the code. And I think that looks much better. So our modal functionality is working well and looks fantastic on our UI. So now let's have some fun and scrape the Amazon website for textbook data pertaining to some of the TIOBE index programming languages that currently don't have any textbook data associated with them on our UI. So let's run our Web API project so that our webhook is appropriately listening on our local machines. I'm assuming you haven't stopped ngrok from running. If you have, you'll need to appropriately run the ngrok command and then appropriately update your delivery preference URL field for your scrapers so that BrightData can call your webhook running on your local machine. Let's open our test scraper console application. Let's assign C++ to the input variable here so that we can scrape textbook data relevant to the C++ programming language from Amazon. Let's run the test scraper console application in order to kick off, as it were, the Amazon 2 scraper. Great, and you can see that it is running on the BrightData platform. So let's go to the output window for our Web API project that contains our webhook code. So it looks like the relevant textbook data has now been scraped and captured from the Amazon website. Okay, so let's have a look at our Blazor UI, which should now contain a carousel with textbook items related to C++. And look at that, that looks excellent. Let's scrape Amazon for textbook data relevant to the Go programming language. Wow, that was pretty fast. Okay, I'm having fun. Let's scrape textbooks for Fortran. And that looks awesome. So I hope you have enjoyed and benefited from going through the first part of this course. If the second part has not yet been published, rest assured it will be published to this channel fairly soon. Just a reminder that all of the code created in this part of the course is available on GitHub. All relevant links are in the description of this video. The web scraping code can be found at this location, the webhook code can be found at this location, and the Blazor application can be found at this location. You can get credits for using BrightData services by clicking on the relevant link that I have included below in the description of this video. So if you like this video, please hit that like button and please consider subscribing to the channel. Please also ring the bell so that you'll be notified of future content released from this channel. Please feel free to share this video with anyone you feel may enjoy and benefit from its content. If you'd like to thank me by buying me a coffee, you can do this at my Buy Me a Coffee webpage at this URL. It will of course be greatly appreciated. It would be great if you followed me on X. My username is @GavinLonDigital. I love reading your comments, so please feel free to engage with me in the comments section. A very special thank you to BrightData for sponsoring this video. I hope to see you very soon. Thank you and take care.